Welcome, Andriy, to the Hive. Hello.
Hello, Chris.
Good to see you. And we also have Yuri here, who's going to help translate. Good to see you.
Hello, everybody.
So let's start with a little background on yourself.
Расскажи немножко о себе, Андрюха.
Я пришел в 3D как традиционный художник. Некоторое время я использовал различные 3D-пакеты перед тем, как я познакомился с Houdini. Но когда я познакомился с Houdini, это было бах, потому что это пакет, который мне дает безграничные возможности. Я ограничен только собственной фантазией и больше ничем.
So Andrew came here from like traditional background. He is a painter and a sculptor, and then he used a lot of other softwares. But when he started to work with Houdini, that was just mind blowing. And the only limit was his imagination, and that was the most cool thing to work with Houdini.
Excellent.
Я хочу сказать, что вы, ребята, настоящие волшебники и безумцы одновременно, потому что вы создаете такой бесподобный пакет.
So he wants to say thank you and calling you like a magician and madman, because it's incredible to do such a beautiful soft.
Well, we'll pass that message on to the R&D team who make all that magic. They're an amazing team. So what's your presentation on today?
О чем презентация твоя будет?
Моя презентация будет о Vellum Close симуляции в Houdini. Я проведу слушателей от создания, от моделирования предметов одежды, потом назначение атрибутов, симуляция и некоторая постобработка. И покажу, что теперь нет необходимости прыгать из пакета в пакет. Все можно сделать в Houdini наилучшим образом.
So Andrew will show his approach to work with cloth in Houdini, like from modeling to simulation, and he also will prove that there is no reason to jump from one soft to another. You can use only Houdini to do all the stuff.
Excellent. Well, let's get started.
Okay, давайте начнем.
Всем привет! Сейчас я расскажу о том, как я создавал физические свойства различных видов ткани, которые видите сейчас на этом видео, используя Houdini Vellum. Vellum симуляция состоит из нескольких этапов, связанных между собой последовательно. Первый этап — это моделинг самой ткани и моделинг геометрии коллизии, и моделинг и анимация геометрии коллизии, на которой непосредственно потом будет симулироваться наша ткань. Второй этап — это назначение атрибутов ткани, собственно, превращение нашей входящей геометрии в ткань. Такие атрибуты, как масса, density, stretch, bend и многие другие. Третий этап — это введение каких-то дополнительных условий в нашу симуляцию. Условия могут быть разнообразные, тут может быть большое количество нод. В моем случае я просто привязал нашу верхнюю часть этого условного рукава к входящей геометрии условной руки. Четвертый этап — это сама Vellum симуляция с довольно большим количеством настроек, и каждый из которых влияет на внешний вид нашей симуляции. И четвертый этап — это постпроцесс, который тоже очень важен, потому что тут вводятся какие-то дополнительные моделинговые операции, которые либо добавляют толщину нашей ткани, либо сглаживают какие-то складки, или, ну, тут может быть тоже много чего. Итак, первый этап, этап моделинга. Ну, я думаю, что нет нужды объяснять, что для того, чтобы получить красивую финальную симуляцию, ваш первый этап моделинга должен быть безупречным. То есть одежда должна быть красиво, иметь красивый силуэт, она должна быть пошита по каким-то определенным канонам. Вот. И чем интереснее, эффектнее вы ее задумаете в начале и замоделите, тем интереснее и эффектнее она будет выглядеть в конце. Это то, что касается внешнего вида. Что касается сетки самой. Сетка, давайте так. Чтобы получить достаточно мелкие складки, чтобы эти складки были разнообразные, как бы где-то они были мягкие, где-то накапливались и были достаточно резки, да? Чтобы можно было проявить какие-то дополнительные свойства ткани, допустим, как вот тут вот легкая помятость. Для всего этого вам нужна довольно плотная сетка. Вот. Значит, да, сетка должна быть плотная, если вы хотите добиться реализма. И да, симуляция будет тяжелая, потому что большое количество точек, как бы, естественно, отразится на времени симуляции. Но результат того стоит. Для себя я нашел такую, как бы, среднеарифметическое между, как бы, достаточной плотностью сетки, достаточным количеством точек и времени симуляции. Я пришел к тому, что, ну, для меня, по крайней мере, достаточно, чтобы расстояние между точками, то есть расстояние между вот этой точкой и вот этой, было где-то в пределах 3-4 миллиметров. Если речь идет о каких-то достаточно мягких тканях. Значит, как это померить? Сразу возникает вопрос. Ну и для себя я вот сделал такой способ, который работает абсолютно со всей геометрией, пусть то пришла геометрия из ZBrush или геометрия, которую вы сами моделите. Это мы сначала конвертируем в сплайны всю нашу геометрию, вот, и замеряем длину этого сплайна. А потом мы нашу примитивный атрибут длины сплайна мы переводим в detail с условием promote метод average. И в detail атрибутах, в geometry sprite мы можем посмотреть получившиеся значения. Ну вот у меня сейчас значение между 3 и 4. Это меня вполне устраивает. Что еще важно понимать на этом этапе? Что на этапе моделинга вы уже можете влиять на этап симуляции. Каким образом? Увеличивая или уменьшая полигоны в каких-то местах. Допустим, в местах, которые вы хотите, чтобы выглядели, чтобы ткань выглядела более жесткой, вы там можете просто уменьшить плотность полигонов. Полигоны могут быть в этих местах больше. В местах, где вы хотите, чтобы ткань образовывала большее количество складок, вы увеличиваете количество полигонов, делаете их мельче. Вот. Также направление эджей. Если вам надо задать направление складок, допустим, по диагонали, вот, то вы на этапе моделинга просто направляете эджи по диагонали. И таким образом потом в симуляции у вас именно по диагонали будут образовываться вот эти вот складки. Значит, сетка, состоящая из треугольников, будет себя вести иначе, чем сетка, состоящая из регулярных вот таких вот прямоугольных полигонов. Потому что в данном случае у нас, получается, все точки расположены в какой-то такой регулярной последовательности. Если мы сделаем ремеш и сделаем всю сетку из разнонаправленных таких треугольников, во-первых, сами треугольники будут уже иметь разную площадь, вот, в отличие от вот этих прямоугольников, и как бы точки будут разбросаны более хаотично, что в итоге отразится как бы и на этих складках, которые они потом образуют. В общем, вам, если вы хотите добиться интересного результата, то, конечно же, вам придется поэкспериментировать с разной плотностью сетки и с треугольниками и прямоугольниками. Вот. И почувствовать, просто надо почувствовать эту закономерность. Так, оставим на время этап моделинга и перейдем к следующему этапу. Значит, этап назначения необходимых атрибутов для симуляции. Ну, что у нас тут из такого, из важного? Как бы эти этапы, эти параметры тут у меня практически по умолчанию стоят. Ну, там с небольшим изменением, как бы это, с этим вы поиграете сами. Драг у нас в основном при такой плотности сетки от 3 до 4 миллиметров. Драг у нас будет, ну, как бы у меня получался, будем говорить так, где-то normal drag 80. И тангент драг, соответственно, тут в 100 раз меньше. Но это не всегда, не с разными типами ткани чуть-чуть оно по-разному работает. Где-то чуть больше, где-то чуть меньше. Но в среднем вот около 80 normal drag, может быть до 100, ну от 60 до 100 где-то вот так вот. Средний параметр 80. Ну и соответственно тангент драг тоже там как бы делите на 100. Вот. Стрейч для вот этого конкретно примера значения не имел. Как бы тут у меня бендинг самой ткани отрабатывается, и растяжение как таковое, оно тут минимальное, то есть оно тут на внешний вид ткани вообще почти не влияло, поэтому стрейч в данном случае я просто загнал вверх, сделал тут как бы, чтобы ткань совсем не растягивалась, вот. А вот параметры бендинга я накручивал в разные стороны очень активно. Вот. И должен сказать, что тут можно добиваться потрясающих результатов. В данном случае с шелком тут я просто как бы увеличил, ну, уменьшил сопротивление как бы до такой очень большой величины, да, и дампинг ратио сделал немножечко побольше, этого хватило. Но в случаях с другими материалами, такими как кожа или что там еще у меня было интересного такого, шерсть, джинс, там я активно использовал, вот, допустим, stiffness дропов и enable plasticity. Допустим, вот этот параметр enable plasticity дает потрясающие результаты. Можно как бы создавать эффект поношенности ткани, не моделить его, как бы не рисовать его, допустим, бампом или там дисплейсментом какие-то складки на отсимулированной уже ткани. И это всегда дает такой не совсем естественный результат. А именно в процессе симуляции, как бы там, где сустав согнулся, в этом месте как бы образовываются складки, которые остаются потом на долгое время, даже при разжатии этого сустава, как бы они все равно там считаются, и это выглядит, дает такой очень реалистичный эффект. В общем, этот параметр может творить чудеса, Enable Plasticity, но, конечно же, он нуждается в разумном использовании. Не везде и не всегда. В данном случае с шелком, именно с этим типом шелка, я это не использовал. Ну, в общем, тут в Vellum Constraint имеется большое количество и других настроек, про которые я сейчас рассказывать не буду, потому что не хватит времени, и это не является сейчас предметом данного разговора. Четвертый этап – симуляция. Решающее значение тут имеют субстепы. При моей плотности ткани 15 – это где-то среднее приемлемое значение субстепов. Надо сказать, что я использовал его почти всегда, именно в этом примере. Независимо от того, был ли это шелк или была это кожа. Вот. При меньшем количестве субстепов полигоны начинают растягиваться и дрожать, в общем, вести себя неадекватно. Точность симуляции сильно падает при меньшем количестве, а при большем уже как бы, то есть при 15 качество довольно высоко и как бы просчитывается все довольно неплохо, а допустим 20-25, изменения не так велики, да, и что-то меняется, вот, причем, кстати, не всегда в лучшую сторону, вот, но при этом очень сильно вырастает время, увеличивается время симуляции, поэтому я вам рекомендую 15, как бы, исходя из своего опыта. Два следующих параметра тоже интересные. В данном случае второй параметр Constraint и Iteration я оставил по дефолту, вот, а вот Smoothing и Iteration я сделал в 0. Для чего это сделано? То есть что вообще делает этот параметр? Он как бы наши, получается, как бы атрибуты, да, наши, просчет итераций в каждой точке, он его как бы разглаживает как бы распространяет немножко на соседние точки, да, как бы вот, допустим, он посчитал, что у нас где-то там, я не знаю, вот происходит какой-то такой довольно сильный залом, да, и он это как бы слегка размазывает по поверхности нашей ткани, вот, но в данном случае это хорошо для многих случаев. Вот. Также это хорошо, чтобы избежать разных там эффектов дрожания, и там прочих ненужных вещей. Вот. Но в моем случае как бы, это мешало образованию таких вот маленьких красивых складочек. Вот. Поэтому я его убрал в 0. Вот. И мне пришлось немножко поднять вверх, накрутить Collision Path. Почему? Потому что у меня начинались те же самые дрожания. То есть, в общем, чтобы выровнять качество симуляции. Поэтому тут я немножко снизил, тут поднял. Вот. И вот эти вот два эффекта, как бы вот эти два параметра, они, как сказать, радикального значения не имеют, но как бы они были, я их чуть-чуть подкрутил, мне показалось, что это неплохо. Вот. Но, как я уже сказал, то, что действительно влияет на качество симуляции в этой вкладке, это параметр substep, этот, smooth iteration и collision passes. Дальше, значит, в силах я уменьшил немножко трение, поскольку это шелк, и он должен как бы скользить, получается, по геометрии, с которой он коллизится, он должен так плавно соскальзывать, поэтому я чуть-чуть уменьшил его трение. Вот. Про это не говорим. И практически всегда я отключал OpenGL и Normalize Stress. Ну, почему я это делал? Как мне показалось, оно немного ухудшало качество моей симуляции в данном случае. Именно вот когда мне нужен бендинг. Когда ткань летит в свободном полете, это не так важно. Но вот когда это какой-то рукав или штанина, то мне пришлось отключить это. Возможно, я был неправ, не знаю. Вот. Так что, как бы, вам предлагаю обратить внимание на это и на это. Остальное попробуйте, может, вам понравится как-то по-другому. Так, пятый этап – это этап постпроцесса. На этом этапе мы сделать можем тоже очень многое. Сейчас я просимулирую немножечко нашу ткань. Ну вот, я просимулировал до 24 кадра. Теперь посмотрим внимательно на Vellum постпроцесс. Что у нас тут? В общем, на это, допустим, мы его отключим сначала. Вот такая геометрия у нас пришла из Vellum Solver. Vellum постпроцесс может сделать просто subdivide. Вот он сделал subdivide. И уже у нас сгладились вот эти вот складки, которые были из таких крупных достаточно полигонов. 3 миллиметра это довольно большое расстояние вот между точками. Ну, вернее, там сколько у меня? 3,7, да, почти 4 миллиметра. Довольно большое. Но после того, как мы сделали subdivide, у нас получается тут уже что? Меньше, чем 2 миллиметра расстояние между точками. Это уже как бы повышает реализм нашего целого изображения. Вот. Это нам дает возможность в 4 раза меньше получается точек подавать в Vellum Solver. Только благодаря тому, что мы можем сделать subdivide уже после симуляции. Вот. Это, как мне кажется, это уже большое дело. Дальше. У нас есть, мы можем разблюрить немножко вот эти вот складочки. Это тоже очень хорошее дело. Сейчас, допустим, мы уберем subdivide, да, и покрутим просто blur. Вот. Мы можем, не накручивая subdivide, но как бы используя только вот этот параметр блюра, сделать уже такой гладкий эффект. Вот. Можем использовать и то, и другое, да, и у нас получится как бы что-то третье уже. Вот. Значит, плюс мы можем сделать толщину, сразу задаем. Вот. Толщина у нас работает по параметру particle scale, да, scale каждой точки, как бы задается, умножается на вот этот параметр. То есть мы можем, допустим, сделать 0,1, да, и будет у нас толщина как бы такая тоненькая, но толщина будет иметься, и это нам как бы в дальнейшем для рендера как бы очень сильно пригодится, эта толщина. И также есть еще Тоже очень интересный параметр. Я его в данной ситуации не использовал, вот, но ну, как бы задача не стояла. Но если вам нужна, допустим, мокрая ткань, да, которая лежит как бы на мокром теле, да, то тут есть очень интересный параметр, который вот делает такой вот эффект как бы прилипания к геометрии коллизии, и получается у нас такой достаточно интересный эффект намокания как бы и прилипания. Так что, ну вот, будете делать персонажа под дождем, как раз этот параметр вы будете использовать очень активно. Теперь давайте посмотрим на Vellum постпроцесс в моей имитации кожи. Что я тут сделал? Ну, первое, что я очень сильно увеличил толщину ткани. Как бы я P-scale умножил на 5, что мне дало возможность как бы, ну, создать такой как бы эффект массивности этого как бы куска ткани. Посмотрим. Так, пришла мне после симуляции такой. Вот складки тут, видите, такие тонкие достаточно. И когда я включаю Vellum постпроцесс, они увеличились и закруглились благодаря вот этому вот блюру позишена точек, который я включил на 0.3. Вот, таким образом, как бы уже после симуляции я как бы добил, докрутил внешний вид этой геометрии, чтобы она, ну, как можно больше походила на кожу, которую я пытался сымитировать. Мне кажется, имитация довольно неплохая вышла в этом случае. Сейчас я вам покажу уже отсимулированный кусок. Что вот тут интересно? Помните, я говорил о параметре Enable Plasticity в бендинге. В данном случае он включен, и посмотрите, как он красиво отрабатывает какие-то заломы на ткани. Получается, что даже вот после сжатия ткань помнит, в каких местах она сжималась. Обратите внимание, как вот эти складки, которые ткань сохраняет, они хранятся до какого-то момента натяжения, да, довольно долго. Вот. А потом, в момент максимального как бы напряжения, они разглаживаются. Вот, допустим, в этом месте. Что создает очень реалистичный эффект. Вот тут, допустим, она где-то еще чуть-чуть помнит, ну, как бы вот тот залом. Такого эффекта дисплейсментом или бампом вы не добьетесь. Это можно сделать только симуляцией и только при вот этой функции Enable Plasticity. Из остальных настроек, что тут? Ну вот бендинг я загнал высоко вверх, потому что эта кожа, она достаточно жесткая. Значит, тут у нас все точно так же, как и в предыдущем варианте, потому что условия не изменились. Вот. Vellum Solver все те же 15 субстепов. Вот. Но тут я добавил Constraint Iteration, 50 еще добавил к тем 100 по умолчанию, которые тут были. Вот. Smooth Iteration у меня тут опять 0. Вот. И Collision Pass мне не понадобилось увеличивать, потому что, ну, симуляция и так хорошо отработала свое. Так что я оставил по умолчанию. Ну и немножко поиграл с силой трения. На примере симуляции кружевной ткани я хочу показать возможности использования дополнительных атрибутов в Houdini. Надо сказать, что тут имеются безграничные возможности. Вот, и ну, по сути, вы ограничены только своей фантазией. Все, что вам может прийти в голову, вы можете ввести в свою симуляцию как атрибут и каким-то образом повлиять на внешний вид симуляции. В данном случае я использовал атрибут Bend Stiffness вот, для того, чтобы передать разнородность ткани. У меня в кружевах использовались... Ну, что такое кружево? Это сетка, да, очень мягкая, вот, на которую нашиты какие-то дополнительные узоры. И эти узоры достаточно жесткие. В моем случае узорами у нас являются звездочки. Так, сейчас я их покажу. Бам-бам. Вот stiffness. Давайте мы его сунем в цвет. Вот оно. То есть все черное в моем случае это должно быть сетка и вести себя как сетка. Вот. А звезды вот эти это должно быть как вышивка на этой сетке, и соответственно они должны быть намного более жесткими и вести себя ну, совсем по-другому, чем вот это черное поле, которое их окружает. Для этого я тут заводил несколько атрибутов, но в итоге потом использовал только один, вот этот Bend Stiffness. Значит, цвет мы отрезаем, выходим наверх. Ну, суть этого действия, в общем-то, очень проста. У нас есть stiffness, который довольно высок, ну, не довольно, он очень высок. И мы этот stiffness умножаем на вот этот вот атрибут Bend Stiffness. Вот. Потом все это в симуляции просчитывается, и в конце мы имеем вот такую вот историю. Это будет видно лучше всего на вот этом, наверное, не лучше, наверное, без света, вот тут, на вот этом примере. Вот, обратите внимание, не, все-таки лучше с цветом. Обратите внимание, что ткань в некоторых местах как бы сразу сгибается, образовывает мелкие складки, и в некоторых местах такие пустоты, которые не гнутся. Вот особенно вот в этом месте видно. Что это такое? Сейчас мы посмотрим, подключив сюда еще... А это как раз вот эти места, где находятся наши звезды. То есть между звездами ткань сгибается, а там, где звезды, ткань жестко держит свою форму. Вот. И в итоге вот мы имеем вот такую штуку. Такое поведение, которое нам... очень неплохо иллюстрирует поведение кружевной ткани. В этом случае я активно использовал моделинг уже после симуляции, для того, чтобы придать больше натурализма нашей кружевной ткани. Я сделал несколько операций моделинга, использовал, например, higher ноду для того, чтобы создать стежки ткани, стежки, ну, вышивки. Вот они. И отдельной веткой у меня идет сейчас, это фонд, вот. И отдельной веткой у меня идет сетка. Я оставил только эджи и убрал полигоны. Вот. И у нас получается... Дайте нам сеточку. В итоге я получил вот такую историю. Сетка, на которой есть вышивка звезды. Ну, которой был вполне доволен. Предлагаю вам использовать тоже что-то подобное. Больше всего моделинга после симуляции я использовал, конечно, в имитации шерсти. В данном случае я буквально замоделил полностью всю вязку. Вот. Сейчас покажу. Вот такая у меня труба, как бы с замоделенной вязкой, в которой просчитаны все ниточки. Вот. И потом point деформом просто отдеформирована уже под нашу геометрию, которая пришла из симуляции. Ну и дальше там несколько нот, чтобы покрасить и материал. Вот. И все это органично, единым потоком, то есть геометрия, да, моделинг, потом назначение атрибутов, симуляция, да, и после этого мы еще добавляем такую довольно большую сеть моделинга, которая моделирует вязку, и в итоге на выходе получаем довольно симпатичный такой шерстяной рукав, да. Это основные моменты, которые я хотел показать в симуляции облегающих предметов одежды, ну как не облегающих, а, скажем, не свободно парящих предметов одежды, таких как рукава, допустим, штаны, футболки, ну, вещи, которые идут вдоль тела, вот, в которых важен именно бендинг. Если вдруг кому-то покажется, что я что-то недостаточно раскрыл, или есть какие-то вопросы, то пишите в комментариях, я постараюсь всем ответить. Симуляция предметов одежды, которые свободно развиваются, таких как юбка, шарф, ну и подобные вещи. Что тут важно понимать в первую очередь? Что настройки симуляции из предыдущих вариантов, ну, таких как рукав или там штаны, не могут быть напрямую перенесены сюда. То есть, например, если у вас вверх какое-то платье с рукавами, да, а внизу у вас юбка, и все это подразумевается, что все это из одного и того же материала пошито, то свойства ткани вам придется настраивать несколько отличающимися друг от друга. Потому что в одном случае вам надо сосредоточиться на красивом бендинге и образовании красивых складок непосредственной близости от предмета коллизии. Вот. И в другом случае вам надо будет сосредоточиться на том, чтобы как можно красивее передать свободный полет этой ткани. Вот. И, соответственно, вы будете дергать эти параметры в разные стороны. Что тут приобретает значение? Приобретает большое значение масса ткани. Вот. На нее стоит обращать большое внимание. Драг имеет огромное значение. Вот. Бендинг продолжает иметь большое значение. И стрейч тоже, значение стрейча тоже очень увеличивается. Потому что, допустим, такие ткани, как джерси или, ну что еще, некоторые виды шелка, они довольно сильно растягиваются. Допустим, когда она летит в свободном полете и вдруг сталкивается с каким-то предметом, с которым она коллайдится, эта ткань, в этом месте она начинает тянуться. Вот. И это уже становится заметным глазу, и поэтому это надо стараться передать в нашей симуляции. Что еще из таких принципиальных моментов? Вот что, значит, в данном случае юбка, где она у меня, вот она, нижняя часть ткани, у меня уже сделана из треугольных полигонов. Почему? Потому что создать более-менее равномерную сетку из прямоугольных полигонов на вот такой вот расходящейся в разные стороны конусообразной поверхности представляется довольно проблематичным. Вот. Поэтому наилучший вариант тут это именно треугольники. Также, сейчас где оно у меня, вот тут, если мы посмотрим на расстояние на среднее расстояние между точками, то оно у меня тут чуть-чуть больше, оно 4,2 миллиметра. Ну, как бы совсем на чуть-чуть больше. Вот. В данном случае меня не интересовали очень мелкие складки, и как бы этот вариант, ну, это был оптимальный компромисс между скоростью и реализмом. В настройках симуляции Vellum Solver мы продолжаем использовать вот эти три параметра, о которых я уже говорил, плюс большое значение и приобретает параметр Gravity. Но тут логика проста. Чем ткань тяжелее, чем ткань плотнее, тем она быстрее падает на землю, и, соответственно, этот параметр увеличивается с отрицательным значением. Вот. Да, есть параметр drag в настройках Vellum Constraint, но только он не справляется до конца с поставленной задачей, и нам приходится подкручивать и там, и тут, чтобы достичь наиболее реалистичного результата. У тяжелых тканей будет цифра, значит, меньше, чем 9. А у легких, таких как шелк, ну, может быть, допустим, -5. Ну, такая логика приблизительно. И параметр трения тоже имеет значение, потому что ткань не только свободно летает в воздухе, но еще и сталкивается с какими-то предметами. И, соответственно, трение об эти предметы как-то отражается на общем виде симуляции. Также ткань трется сама об себя. Какие есть основные моменты, на которые надо обращать внимание при симуляции многослойной одежды? Допустим, как вот это, когда у нас тут достаточно много слоев. Ну, первое, это что, если есть возможность, то надо стараться просимулировать их все по отдельности. Допустим, джинсы тут у меня просимулированы отдельным слоем. Сейчас покажу. Вот они. И как бы они у меня там сами по себе как-то живут. Вот. Но далеко не всегда представляется возможным это сделать. Например, секунду. Например, в данном случае у меня есть толстовка, есть куртка и есть рюкзак, которые переплетены между собой. Вот, и они не могут быть, какая-то из этих вещей не может быть просимулирована по отдельности от другой. Это должно быть единый поток симуляции, чтобы все корректно и правильно просимулировалось, и одна вещь влияла на другую. Вот. Что надо сказать? Что вообще-то Houdini очень хорошо справляется с подобными вещами. То есть я был реально удивлен, насколько легко это дается Houdini. Да, надо подождать немножко больше времени, но если вы сказали, что эта ткань не должна пересекаться, ну то есть если у вас в стартовой позиции ткани между собой не пересекались, то проникновение при должном количестве субстепов в Vellum Solver проникновения точно не будет. Вот, и все просчитается очень корректно. В случаях, когда вам надо одновременно просимулировать несколько слоев одежды, и эти слои достаточно затейливо между собой переплетены, вам будет необходим атрибут рестовой позиции. Вот. К нему достучаться можно несколькими способами. Один из способов — это в Vellum солвере, в .NET. Вот. Вы можете прикрутить Vellum REST Blend и тут указать группы, на которые эта рестовая позиция должна влиять. Ну, в моем случае это Bend и Stretch. Вот. И также указывается, из какого места это брать, из какого места брать геометрию, что у нас считается рестовой позицией. В моем случае это REST 1, вот он. То есть у нас рестовой геометрией считается вот такие вот вот такая вот шняга, грубо говоря. Как вы можете заметить, все между собой очень сильно пересекается. Все предметы очень полно, как между слоями, так и слой сам с собой тоже очень сильно пересекается. Вот. Но тут у меня именно тот вид геометрии, какой я хочу видеть в конце симуляции. То есть та площадь ткани, каждая ткань занимает необходимую мне площадь. И отдельно у меня есть не рестовая позиция, вот, а так сказать стартовая позиция, где у меня эти же предметы одежды. Вот, я их просто домоделил, вернее не помоделил, а деформировал, изменил позицию точек, не изменяя количество точек, но изменяя их позицию. Я сделал так, чтобы не было пересечений между этими деталями одежды. Вот. И вот таким вот образом Vellum Solver потом берет эту позицию, где пересечений нет, да, но смотрит при этом на вот эту рестовую позицию. Вот. И симулирует нашу ткань. В каждом кадре он пытается вот эту нашу позицию стартовую приблизить к вот этой вот позиции рестовой, которую мы указали. Но при этом так, чтобы наши точки, чтобы наши поверхности не пересекались. И мы получаем на выходе вот такую вот красивую, непересеченную, видите, геометрию. При том, что, обратите внимание, вот эти вот складки я ему подал в Vellum Solver еще в рестовой позиции. Сейчас покажу. Tab 0. Какой из них? Вот оно. Вот моя кожаная куртка, будущая кожаная куртка уже со складками. Чуть ниже я расскажу, каким образом я сделал эти складки. Вот. И Vellum Solver из вот такой вот гладенькой, абсолютно покатой курточки в итоге нам в конце, через 8 кадров, через 9 в этом случае, он выдал нам вот такую вот геометрию, уже похожую чем-то на кожаную куртку. Должен сказать, что вот этот вариант, о котором я только что рассказал, он больше актуален для Houdini версии 18.0. В новой версии Houdini 18.5 появился новый оператор Vellum Brush, который сочетает в себе свойства вот этого оператора Vellum Solver, и плюс еще там добавлена возможность интерактивного воздействия на ткань. То есть вы можете просто подергать ее, поправить где надо, и сделать необходимые манипуляции уже на лету, буквально когда ткань сама симулируется. Вот. И это дает, конечно, невероятные возможности. Вот это вот сочетание и интерактивного подергивания, и поправления ткани, и в то же время она смотрит на на ту рестовую позицию, какой она должна быть. Итак, после того, как внешний вид одежды меня стал удовлетворять, ну, то есть нету пересечений и складки, которые образовываются, мне нравятся. Вот. Я переназначаю атрибуты уже с условием, как бы учитывая новые условия позиции этих точек. И запускаю основную симуляцию, но только с 8 кадра, потому что тут на 8 кадре я остановился. Если бы в данном случае была Vellum Brush из версии Houdini 18.5, то тогда бы я запустил основную симуляцию с 1 кадра. Что тут надо добавить? Что Collision Pass я увеличил в данном случае, потому что у нас многослойная одежда, и ну, как бы, чтобы во избежание каких-то нежелательных проникновений, я тут увеличил вот этот параметр. И, в общем-то, все сработало на ура. После того, как основная симуляция была сделана, я взял мою геометрию куртки. Обратите внимание, что тут геометрия состоит из треугольников, а мне хотелось, чтобы были прямоугольники и ну, как бы места швов, чтобы можно было хорошо, красиво показать. Поэтому я взял ту исходную геометрию прямоугольники вот, и через Point Deform привязал ее на место нашего ну, куртки из основной симуляции. Таким образом, на выходе я получил чистенькую геометрию, состоящую из прямоугольников. Вот. Потом я это все скинул на диск. Вот я это подтянул с диска. И к нашей куртке без труда я потом прикрутил змейки. Вот они, как бы их тут сейчас не очень хорошо видно. Вот такая вот геометрия, как бы из боксиков, которая у меня имитирует змейку. Сейчас покажу после назначения материалов. Оно смотрится уже более заметным. Вот наша геометрия змейки прикрученная. Ну, вот таким вот образом я получил вполне себе неплохой внешний вид вот этой вот одежды для моего манекена. Теперь небольшое отступление. Для того, чтобы наша картинка была реалистичной, недостаточно только одной симуляции. Должны быть еще текстуры и соответствующий шейдинг. Вот. Что я хотел сказать, это то, что текстуры можно сделать тоже не выходя из Houdini. Вам не нужен Substance Designer или Substance Painter, чтобы сделать текстуры, ну, допустим, текстуру кожи. Вот это вот моя сеть создания текстуры кожи. Все было создано в Houdini, ну, не выходя из Houdini. Значит, вот тут вот некоторые соповые операции, и вот тут вот в коп-нетворке находятся операции композитинга. Значит, заходим в операции. Что у нас в композитинге? Минуточку ждем. Значит, в ВОПе я создал вот такой вот великолепный нойз, достаточно разнообразный. Вот, покрасил его. Потом к нему прикрутил какие-то швы из ниток, да. Вот. Сейчас я покажу, как я создал эти нитки. Создается очень просто в сопе. При помощи, значит так, сначала мы поворачиваем нашу геометрию, говорим ей, что ее position должен соответствовать ее UV координатам, и получаем вот такую вот UV развертку в виде реальной геометрии. Это второй частью Дима, вот тут вот находится у меня. Вот. Потом по этой UV развертке при помощи сплайнов, где мои сплайны? Ну вот один из них. При помощи сплайнов я рисую вот такие красивые строчки. Ну там используя сплайны, ресэмплинг и copy to point. Вот, значит, я нарисовал, вернее, сделал в виде реальной геометрии вот такую строчку, и места, где швы, я тоже сделал в виде реальной геометрии. Также у меня есть вот такая вот штука, это в дальнейшем будет использоваться как рельеф в местах, где швы, там кожа немножко так рельефом загибается, вернее, ну, туда вдавливается наоборот. Вот. И все это в Coop Network подтягивается через ноду Geometry. Вот у меня отдельно подтянуто в виде вот таких вот белых дорожек. Это места швов. Отдельно у меня рельеф этих швов, и отдельно у меня строчка сама. Вот. И при помощи там различных операций композитинга я создаю себе, вот у меня рельеф, вот у меня, если видно, нитка прошита, которая идет в углубление. Ну, там, где темное, там углубляется, да? Вот. То есть у меня есть бамп, у меня есть цвет. Сейчас прочитает. Вот он. С различными тут вариантами покраски цвет. И у меня есть вот это, да, рахнос. Вот такой вот. Все. Потом я это экспортирую выгружаю все это на диск и использую в качестве текстур. И вот такой вот себе незамысловатый ход создания текстур прямо в Houdini. Мало того, ну что хочу, чем удобно как бы именно вот такое использование, ну вернее создание текстур именно в Houdini, тем, что как бы начав создавать тут текстуры, вы можете любой из вот этих вот вариантов вашей сети, то есть любую геометрию из этой сети, да, использовать как способ передачи атрибутов на вашу симуляцию. И обратно вы можете из симуляции вытащить какие-то атрибуты и подать на эту геометрию, и потом ее использовать. Этот атрибут из симуляции вы можете использовать для того, чтобы затекстурировать вашу одежду. То есть очень удобно. Одно перетекает в другое, получается.
All right, next up we've got Jeff Wagner. Hey, Jeff.
Hi, guys. Hi, Chris.
So for the 2 or 3 people that don't know you, maybe you could give us a little background on yourself.
Yeah, I'm senior technical consultant at SideFX. I troubleshoot Houdini. I deal with customers. I'm always looking for new ideas and sharing everything and anything that I know about Houdini. Yeah, and it's exciting to be able to do what I'm doing today. Thank you, Chris, for inviting me.
Excellent. Well, give us a little rundown on what you're going to talk about in your presentation.
I've got this tradition of covering what are the TD features inside of Houdini 18.5 or in previous releases, and I want to cover that for Houdini 18.5, looking at all of those features that are relevant to TDs and TAs. And Houdini 18.5 has got more features than any previous release I've ever looked at, relevant to expert users who are very familiar with Houdini. So hopefully this is a quick tour of all of those features, spanning everything from the new Python states, Python handles and drawables, all the way through to SOPs and compile SOPs. We always have to cover that, and everything in between.
Excellent. Well, let's get started.
Great. Would love to. Thank you. Let's go.
Hi, my name is Jeff Wagner. For the next little while, we're going to be taking a look at Houdini 18.5, focusing on what I think are the top features that are under the radar and looking at some of the technology behind some of the features that we have inside of Houdini 18.5. 18.5 is a massive release with a lot of features that were added that didn't make the top reels in the top keynote, but are very significant to Houdini users as they progress and use Houdini 18.5. So this is just an interesting overview of what I think are the top features that we should all know about. And for today, just a little bit of the background on the specifications of Houdini and the system running on. I'm working with Houdini's Gold build version 18.5.351, and it's the Python 3.7.1 release. My machine is an Intel Core i9 10900X CPU, dual CPU running at 3.7 gigahertz, and I have 64 gigs of RAM, and graphics card is a GeForce 2080 Ti. So the first thing we want to take a look at is some dopamine hits that we want to get right out of the way. So first we want to take a look at my first 3. The Pyro Minimal Solver, and it's all on the GPU. The second one, my second top, is Vellum Paint. I'm sure you've seen lots of demos, and I know that there's going to be other Hive presentations on the simulation framework, but I want to take a little bit of a look at the architecture behind it and the choices we made when we developed these tools. And finally, a little bit of polish on the UX and networks. So let's dive into Houdini and see what we can do. So inside of Houdini 18.5.351, we can see that in the technical desktop, we always get the Python shell. And we can clearly see that I've downloaded the Python 3 build 3.7.4. And yeah, let's go. So the first thing we want to do is take a look at Pyro. And we offer 3 different ways to enter Pyro now. 2 I'll show you right now. One of them is from the shelf. And so this was in 18.0, but we expanded upon them with real production presets for 18.5. And we've reworked the material as well. So we have 2 Pyro shaders now, one that gives you the existing workflow we had in previous releases, plus a new one that we have in 18.5. So let's start off with a sparse fireball, place it in our scene. And that builds the traditional workflow that we're familiar with if we're using the shelf tools all at the object level. And I've obviously hit play. We can see that we now get our fireball in our viewport set up with all the presets. And we'll just quickly inspect the anatomy of this particular tool before we actually go and do this all inside of SOPs. Playback's pretty good. And let's go back up to the object level. I like navigating via the tree view. It's very quick to move around. And sure enough, there's our geometry, and then there's our dynamic simulation. Diving inside of our fireball object will give us the workflow where we have a power burst source, which is all new for Houdini 18.5. It gives you one source location for building all of your initial geometry. If we move our display flag to that and we press forward, you can see that it's using this new workflow where we're spitting out points, not a particle system, but points. It's an implicit system that was designed to just give us a really nice starting framework for our Pyro simulations. And if we control middle on that, we can see that we've redone all the fields as well, and all the data that gets fed into the Pyro. We got burn, burst ID, CD. But it's basically burn now has taken over heat, fuel, and everything else. And there's p-scale, which is the particle size, which is actually gets turned into the volume rasterized to build our volumes. Source name and temperature. So burn, temperature, and velocity are the key elements in the new Pyro solver. And if we take a look at the volume rasterized attributes, move our display flag down to here. Here we can see we have our volumes. And again, control middle on that shows you that we have burn, density, and temperature, and velocity. You can add divergence. There are ways to add divergence down here. You can add more fields as you work, but everything is pretty nice and available for you here. You can even blur the velocity, which tends to diffuse the velocity, making things a lot softer. And you can actually blur the velocity over time for very, very fast moving volumes to sort of alleviate that issue that we always had with substepping. Blurring the velocity voxel over time tends to smear out the put-puts that we sometimes get in simulations. Now we round trip out into the Pyro simulation, and then we come back in with the object merge. And there's our basically bringing in all of our fields, and then we put down the new Pyro bake volume, which actually also has built into it all the shaders that we need to work with our Pyro. So if we uncork this, right mouse on it and say allow editing contents, we can dive inside of this. We can now see the basic framework of everything that's inside of this Pyro simulation. Again, all in geometry. You can see that we have a whole bunch of reshaping of the VDB fields. And the part that I wanted to cover here is the material network. So inside of the mat net, we can see that we have the Pyro shader. And so it supports the new workflow, taking in the fields that we have designed. We also spent a lot of time, I'm just going to tie that up again, match current definition. We also spent a lot of time matching the render look to the actual Pyro look as well. And so we can demonstrate that. Let's go a bit further back. And let's add an output driver. I'm going to do Mantra for now. Render Mantra PBR. And let's now fire up a render pane in here. We can grab that and put that in there. There's no lights currently in my scene, so it'll just use the headlight. And we can see pretty close matches to what it is we're doing now. So trying to get address all those issues that we've had in the past dealing with working with Pyro. And it's a low resolution that we're at right now. And all the other, you can see here, opacity samples need to be increased. We can do all of that. Standard workflows apply. So it's not that different when we actually get to the result, other than we have far fewer fields, much more efficient. So that's the first way we want to work. And the second way is if we just put down a SOP. So let's put down a geometry object. Let's call this fire. Dive inside, and we can now right mouse or tab the network view to actually get our list. And let's go to the Pyro shelf tools now. We can see that we have a whole bunch of configure options in here, and these are fairly equivalent to shelf tools. But what they now do is actually add the entire setup right inside of the SOP context. So let's choose something a bit different. Let's do a Pyro configure GPU, or let's actually do the ground explosion first of all. And that will actually build a network for us that will set up the anatomy of a Pyro simulation that will actually do a ground burst fire in this particular case. And once it's complete, completely different setup now. And we're now entirely inside of SOPs. So if we then take a look at let's say the initial start frame up here. We can press forward. We can see that there's the initial points that we want to work from. So in this case, we have 3 points in our scene that we want to work with. And I'm going to change my viewport to dark because that makes it look a lot lighter. And we can offset the start frame. And this allows us to shift the start time of our simulation, and then the pyro burst source, which is actually again what we use to generate the points from those initial seed points. And of course if you offer more seed points, you're going to get more seed points. And again, control middle on that gives us the exact same thing: burn, temperature, and velocity. And in this case, we actually have a divergence field as well as there, and we're carrying density for smoke. So an additional 2 more fields that are key to what we need to feed this new pyro solver with. And of course, then we have the pyro solver ground explosion. So this is where you want to go when you really want to start studying the new pyro framework. You might be working in an existing studio that has your own pyro tools. You might have adapted them to Houdini 18.0's adaptive solver. That's great. But these tools are designed to show you a really great way to get a starting point for doing enterprise type simulations, for doing classic type sims. You lose none of the control, even though that we have minimal fields available to us inside of the pyro solver. You can actually dive inside of the solver and add your own microsolvers. For instance, you can dive inside of the microsolver here, and you can build your own microsolver framework. You can do any sort of advection. If you want to advect the fuel, you can actually introduce fuel, advect it, and as long as you export out a burn field out of this that will work within the slots that we have, it'll be great. Plus, you can carry your own fields for doing shading and rendering. If you wanted to add some unique colors or other things, you had the full gas microsolvers available to you in here that you've always had before. A nice playground to work inside. Just be wary that if you do any work inside of here and you choose to use the minimal solve option inside of the pyro solver, right now it doesn't get used. There's only very few solvers that you could put in there that actually would work with if at all, work with the minimal solve. The minimal solve is mostly just straight aheads, but we're not using minimal solve here. It's still adaptive pyro. And again, all the same other framework. We also have again, the Pyro Bake Volume, which is our backend tool for creating the fields for doing final rendering and applying the shader as well. So really nice way of working. Now, the other one I want to show is the GPU solve. Obviously, there's going to be a lot of other people covering this, but I just wanted to do a quick look at the actual, so let's do Pyro Configure GPU. If you do have a GPU that's worthy of doing these simulations, then definitely use the GPU. We're sort of saying that it has its role is to support the look development of particular pyro simulations, and it does work in a fixed container size, and because that's just the way that we have to present it to the GPU, and it's the way the solver is designed. And you can tweak this, and then of course you can always offload it to the to the CPU solve. But it's also very important to realize that this can actually go quite high depending on what direction you're going. Again, if you go to the Pyro Solver, the Advanced tab, that's where we actually have the minimal solve. Now, there's a bit of confusion here. We have the old Use OpenCL option available to us. That's to support existing 18.0 and previous workflows. It is by no means compatible with the minimum open CL solve. As a matter of fact, don't use this if you're using the minimum open solve. And of course, if you use the non-minimum open solve, now you get your adaptive voxels and you can increase your resolution if you blow past your GPU memory. But there's the minimal open CL solve for you. One of the things that we've done is we can actually add collisions on here, and we've implemented nano VDB. So I'm going to just add, I'm going to do creating context option here. That means that I won't create a new object. And let's actually put down a sphere, and let's move the sphere up, and let's make it a bit bigger and place this in our scene. so that it collides with the Pyro, and it's good. Now I want to use this as a collision for my Pyro solver, and so what we can do is we can turn this into a VDB grid using the VDB from polygons. So tab VDB from polygons, put that on the bottom of the sphere, and then we can wire that into the Pyro solver. And again, playing forward, it's not really evident that the sphere is working with the simulation. So let's make it a bit bigger so we can actually see this, and play forward again. And now we can see that the Pyro simulation is evolving around the collision sphere. And it's important to note that at this point in time, we actually have a VDB grid. And we can see we've got a lot more information available to us now as to what version of VDB we're using. So in case you're building against a custom version, it's all available to you. And but what's really interesting is once you go into the Pyro solver, when we're using the minimal sol version, which is what we're doing, where everything's on the GPU, we actually lift that VDB grid into the Nano VDB from NVIDIA's Omniverse, and the tool set that they have. We've been working with them very closely to support VDBs inside of Houdini. So we automatically move that VDB grid into the GPU. So everything is on the GPU at this point in time, straight from the solver into the viewport. And then you can start dialing in all of your different behaviors on the Pyro simulation. So again, it's a really powerful tool. Now, there are ways to actually access these open VDB grids, these nano VDB grids in OpenCL, work with them directly. Definitely have a look at some of the files, and that might be in a subsequent master class, or we'll see if we can explore that even further, how to use these open VDBs in OpenCL directly in your OpenCL tool sets. But again, entirely all on the GPU, and it's just a matter of just going to that advanced set and just basically turn that OpenCL acceleration on or off. Now on to the next feature that I want to take a look at. Number 2 is the Vellum solver, or the Vellum brush solver, and we're going to start off with the pig head. And we're going to put down a solid conform. And this, but it no longer puts on a solid conform, it puts on a tet conform. So we've rejigged all of the solid type tools to rename into tets. So if we do a tet type, you can see that we have tet conform, tet embed, tet fracture, and tet partition. So all the solid tools, they're still there, but some of them have been deprecated. We'll talk a bit more about the new SOPs later on. But tet conform is the new tool for generating tets from your geometry. Now, as always, we need to put down, we have to put down the configure. So Vellum configure, in this case, you do need to put a Vellum configure on all the geometry. It's the barrier to entry to get into Vellum Sculpt. So let's put in tetrahedral soft body, and we can already see we put down the tet conform, but we can bypass that. And let's put the tetrahedral down there, and that actually builds our tets for us. And now we can change some of the properties in here if we so wish, but let's dive right into the Vellum brush. So tab Vellum brush, and we can wire them to the 3 inputs. By the way, if you do the Vellum brush in the viewport, I found out that we only do the first link and you end up with an error, so it's probably best to add the Vellum brush in the network. But anyway, so now we're ready to go. And let's make my interface a bit bigger here. Now there's hotkeys on the bottom. Now remember, this is now viewport state, and we've completely rejigged the hotkeys. Just a word of warning. We can choose volume, surface, screen, nearest point, or connected geometry as the options, and they're all available to us on the top as well. We can do the visualization mode if we want to, but the really big one is all the brush options that we have available on the number keys 1, 2, 3, 4, 5, 6 to do all of the different options on there. And obviously we have F for freeze outside, G for settle, and then live for and then live simulation if you want to turn that on, if you want to actually work with it in simulation mode or not. Again, it's all exposed at the top. At the very bottom, this particular state, which is new for 18.5, we can see here that to resize the brush, it's now Control-Shift left mouse button. So we left the middle mouse button available to do other things. So Control-Shift make the brush a bit bigger, and there's going to be all kinds of different videos on what we can do with these particular brushes. I want to take a look at the Vellum brush in terms of a flow when we actually have to run a simulation on a placed object. In this particular shot, let's say we need to start off based on directional control with this sort of a setup, and what we can do now is we can press this option on the Vellum brush in the parameters reset state. And what that does is it basically resets the state, resets all the rest positions. So now we can take that pose as our start, and then we can put that into a Vellum simulation node or Vellum solver operator. And again, we can place that down. And now we can run our sim. Let's turn the ground plane on. Let's move it down a bit. Something like that, and then you press forward, and the simulation will start with some of the energy as it goes. Yeah, and again, you can tweak all kinds of options, and all the regular Vellum solver workflows work within this architecture. Now I want to take a look at a couple other simulations that I've set up that show a little bit more of the workflow that we were talking about. So we have a basic grid, and pass it through the Vellum cloth, configure it as cloth in this particular case, and then we do the Vellum brush work on this. And again, we press the reset state, and then we can subdivide this to get more detail, and then we can apply second set of Vellum cloth constraints. We can completely reconfigure it as cloth again, and then do another second Vellum brush. In this case, we can tangle it up into a knot, and the inside versus outside. You can see that I used a lot of the middle mouse options to lock some of the points as I was twisting the knot, and then eventually put on a Vellum post-process to clean up some of the geometry. And again, if we wanted to simulate this, we could put this into a Vellum solver SOP and do continued work to this. Another example is using a tube, again using the tet conform, and in this case adding some more Vellum constraints, in this case tetrahedral stretch, and what this does is it tries to preserve the volume, and then another Vellum brush. And you can see here that we can now literally work with this and tie this into a knot, pulling it into each other, and creating a simple knot. And then we can use again the Vellum post process to do more work on it, to basically render it a bit smoother and to add subdivisions. But again, nothing stopping us from adding more subdivisions and continuing on working further forward. And the Vellum brush really is a stateless solver. You can dive inside of it and actually see the basics of what is just a Vellum solver. But this state really does offer a lot of interesting workflows. So now we want to take a look at some of the new tools that we've provided in the actual network editor. And this is number 3. So if we always have the Y key for cutting links, but we've now added a J key where we can just simply stroke through the operators and it wires them together. You have to be a bit careful. As we can see here, the tube went into the wrong input. So if you sort of arc down that, it's pretty implicit as to where that it goes. And I'll show you when we're cutting 3 links, you can hold down again the J key and you can swipe to do the 3. So it's a bit quicker than doing click, 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 click. And another thing we added is new radial menus to the network. So if you hit the N key, N as in Nancy, you can now see that you get this full radial menu. And these are fully customizable. And let me show you where that is. So we just dive down. If we go under Edit, Radial Menus, up way in the upper left-hand corner, This gives us the new, well, it's already existing, but there's some really cool options that we have available to us. So we actually have the regular 3D scene viewer tools, and we can actually go to the network editor. And here we can see our radial menu. So if you wanted to change one of the behaviors on this radial menu, for instance, we want to do down, and in this particular case, it just says, just set the current new working directory as the child of whatever it is that I have currently selected as a node. But we can, I just have a script off screen that I can paste into here. In this case, if not is not type instance, go to the current node, if not dive down. So you can put whatever tools you want in here, and then when you hit the end key you can execute any scripts you want, so it's fully customizable. We also added another type of a node, another type of a quick mark. So if we go to the 3D scene viewer, one good example is the insertion points tool that was added for Solaris LOPS, and that is a completely scripted way of generating a radial menu. So this is brand new, and you can create any one you want by either just duplicating that by hitting the D key, and then you can create your own version, or down in the lower right left hand corner you can actually say a regular menu or a scripted menu, and here you can actually start writing your own scripted radial menu. Again, insertion points is a great place to start to have a look at how to actually define your own radial menu as an example. And so pretty sophisticated workflows here. So great set of tools, a nice update to all the radial menus as well. Next on my list is release support. I can't think of a release that we've had that had more supporting material and more content files available upon the gold release. One of the areas that we did a great job was on the content library. You can see, I just took a snap from it yesterday. We can see all of the new tools and scene files that we added that were used to support the release material. We have the full Eric rig, really nice shotgun publisher tool in the PDG, some explosion examples that are brought to the point where you can do a final render. Also a lot of fabric presets that we were talking about in the release. Also a nice KineFX antenna Vellum setup, KineFX jump rope, KineFX train adaption, the Sophia rig, which is actually an object level HDA, which we can use to import into the new rig tools or start animating right away in the Houdini 18 method way of doing animation, and a lot of other previous files that are of interest that are, so this basically is where we put all of the supporting content for a lot of the presentations that we have. I want to take a look at the Eric, basically the antenna Vellum setup, just so you have a look at it in a bit. But some of the other things that need to be noted is we are shipping with Python 3.7.4 now. And unless you have a pressing need to run Python 2.7, definitely go and get the Python 3.7.4 builds, especially if you're an enthusiast and you've written some Python or not too much Python. You can definitely definitely start testing it for us and using it. I've had little to no issues running Python 3.7.4 in the gold release. And you got to note that it's way at the bottom of the download page. And everything is Python 3.7 except the inline CPP tool and the HQ tool that we ship with Houdini. Those are still written in Python 2. And for those that are using Python, you can take advantage of Future Package, which ships with Houdini. And you can use any of the suggested fixes from the Future Cheat sheet. So you can pause this screen and you can type in this link and get some information as to how you can utilize, the step from 2.7 to 3.7. And of course, I want to go through some preferences and take a little bit of a look at Labs. Labs is still rocking, and there's some really nice tools in Labs that we'll take a look at a little bit later. So let's dive in and take a look at that. So please download all the content on the content library. I'm actually going to open up some of those files. I have an assets directory with a whole bunch of different things, and I have an area for context library, and let's take a look at KineFX antenna Vellum simulation. So double click on there, and there's a HIVE file. I actually took this file and added some motion files to it, and I'll show you where that is. So this is a typical file that we might use. It's an education-based file. It's also requires always a little bit of work to get to work out, but in this case, there's a retarget node in here, and we'll notice diving inside of that, we actually have to download some mocap information. So you just follow the instructions, go and log into Mixamo, and if you've ever seen a lot of the different tools or a lot of the different animations you see in a lot of different videos, really fun videos, you can take a look at the various different sequences. And now with the new tools, all of these FBX animations can be brought in really easily to do and to motivate your characters. It's really a powerful tool set. So by doing that, you actually can learn all the new rigging tools that we have inside of 18.5. That's just an aside. What's most important is this file is now available for you to have a look at. And of course, you can take a look at the various different operators that are used to motivate this particular character. And as I said before, when we do all of this work, you can see here's our antenna workflow. You press play, there's no motion. We output the skin, the rest position, and then the deform pose. So it's intended that you know how to use the deform nodes. So if you if you go into here and you can actually go to the bone deform node, and it has all the 3 inputs. All the capture and skinning information came from the FBX rigs. And now once you do that, you can see that you can bind your motion to it. And yeah, really flexible, powerful solution. And again, there's your seam files, and then you can save this file out and move forward. So all the different files are available for us to work with all these different workflows. And the boring stuff. Definitely have to cover preferences, as I always do. There's some really interesting preferences, more to do with the lighting side of things. So this is all completely rejigged. We've renamed all the different states for doing working inside of LOPS. We can put a new primitive PAP for default authoring within the scene graph. Collections go put into collections. So if I, for instance, was working in environments, I could put in here environments collections, and new primitive path, I might want to put env/os. And that means that any primitives we create in Solaris will now, from this point on forward, will use these particular tools. So if we want to create environment lights, we can put them in a directory called env. So, and transform suffix, we can default it to $OS. We can even preface that as well with, if you want, env as well. And that way, if you're an environment artist, everything you do inside of USD will now be in the end context. We can quickly see that once we press accept. And then we can go to Solaris, again, just looking at presets. And then you can just add a simple test geometry, the crag, and we can quickly light him. Every time you add an area light now, you can see that it gets put inside of env lights, area light, and test geometry crag will come in the way it normally does. But all the ancillary assets that you do for the preferences will show up. A couple other things with the preferences, handles, just a little bit more work on it to support the new handle workflow, and interactive tools, that hasn't changed. So the big changes inside the preferences are inside of lighting. Labs has also been busy. If you don't know or haven't installed the Labs tools, it's a must these days when you're dealing with Houdini. There's a whole bunch of tools for doing FX work, and what these are wrappers around common workflows on top of the Houdini architecture. So it makes it easier for you to do day-to-day work, especially when you're building mesh processing, building levels. A lot of the workflows that are tedious to redo, or you might have to do your assets, you can build all of these assets. And so the currency of almost all the lab tools are digital assets. So it's interesting to see that there's been some really nice improvements in Houdini in that area. If you go to the Vimeo labs website, you'll notice that there's a video from Paul Ambrosian that was released about a month ago that actually has some of the new labs workflow around digital assets. And that's all in part about working with versioning digital assets, where you can create a subnet, right mouse on it, and you can have access to create version digital assets. You can give them a proper namespace, and you can see here you can build up a really nice namespace, prims, default, :1. And it's easy to build these namespaces and then create your new version digital asset. There's even tools that allow you to customize where those assets get placed. So you can actually define via the environments, SideFX labs.json, you can even define what your VHDA path is, so you can have all your assets delivered to that specific location. You can also then, once you've created your version asset, you can actually easily increase the minor version or the major version very quickly. And this is intended to work with assets, because we've realized that many people will use the lab's assets and then they want to make a version of their very own. They don't want to open up the type property. So we finally have a really quick way of creating a minor version on top of an asset, and it'll bump the minor or the major version up. So we finally have a proper workflow to help you work with your digital assets. Again, always link into the Vimeo website and take a look what labs are up to. I'm going to fire up Houdini as well. And one of the other things that I'm using all the time is the crash recovery. And that also is a nice courtesy from labs. One of the things I want to say is, if you're using Solaris and the Hydra Delegate in 18.0, when the Hydra Delegate goes down, it would take down Houdini. And as an aside, in Houdini 18.5, we try to restart the server again before we bring Houdini down. So a lot of these insta crashes have been minimized a lot inside of Houdini 18.5. But definitely take out the labs. If you haven't installed it yet, there's some really nice tools. This one was from one of the internal TDs. Swaab network. So let's add a sphere and dive inside. And one of the things done by Michael Buckley is the ruler tool. Really nice. It uses drawables in the Python viewport tool set that we have made available to you. And so he also recorded this, and it's available online. So labs, definitely a great place to go. Some really nice improvements for 18.5, including the pick and place tool. Please check that out. So next on the list is number 5, viewport features. We've done a lot of work on the viewport, adding fog and depth of field, and we've also added a lot of speed improvements into the Houdini JL, the JL delegate as well, and a whole bunch of other features. So what we want to do is fire up Houdini, and I'll show you how the viewport fog features work. So here I have a simple scene set up. It's just got a simple height field, just a terrain height field, and we've got a camera and a point light looking in our scene. So we're going to set this to cam 1. To take a look at the fog options, you hit the D key in the viewport. You can turn on fog. And we have, very similar to what you would have in Unreal, we have the uniform fog. We can add a sun. And we can also add some volumetric fog, just this general depth volume fog to the scene as well. We're going to take a look at some of the uniform fog options we have here. We can control whether it's below the ground or above the ground. We can increase the density. Let's do no limit. And sometimes we have to sort of tweak the viewport to get it to evaluate. And let's take a look. And it's also the camera as well. If we go back to the camera, sometimes the far clipping plane on the camera is not suitable for the fog. So we notice here the far clipping plane. Let's draw that in, something a bit more reasonable. And now we can see that the fog is kicked in. And now that we're back into fog, we can say the uniform fog, we can adjust the density. 1 is usually a good place to start off with. We can go to 0.01. So then the opacity as well, we can control the opacity. Let's set the fog to 1 again, and we can set the opacity however we want. There's a depth range. We can actually do above the cloud strata or below the ground. And we want to do below the ground. And we can notice that this height is tied into our height field, and we don't really know where that is. So if we start raising this up, It would be nice if we actually had some nice user controls over all of this, and we can do that. There's this node override option here that we can use to actually control these fog settings. So and it doesn't matter whether it's Solaris or inside of the object context. Let's do it inside of the object context. I'm going to put down a null, and I'm going to call this fog control. And on here, we can actually do a node override. And right now, because there's no parameters on this, any parameters that I put on this fog to override this will actually work. And the way you do that is you can right mouse on the fog and you can go to the edit parameter interface on that particular operator. And if we go to node render properties, and you can see already it got the filter in there, but if we put the filter in there for fog, we can see that in viewport displays, we have all of these fog options that are presented here in the parameters available for us to add to this node. So I just press the arrow to point to the right to add to this operator, and then I press accept. And now this fog object all of a sudden takes over. We can see that the node override is set to fog control. Now, because I'm actually, the sun is the only one that's not tied into here, we can see the OpenGL fog light options, fog light scattering, fog light intensity. We can increase or decrease the intensity of any lights in the scene casting through our fog, and that's via the sun. And then also the OpenGL fog params. So if I go here to uniform, now this is now taking over. For instance, if I change the fog color to red, you can see now that I'm controlling the color. Let's set it to a nice blue. And so now we're going to close this because now we have the node override set. We can do the fog depth range as well here. We can do the fog below the strata. Let's do some really nice ground fog. And we can see here we can adjust this. But what we really want to do is give a control to the viewport. So the control actually has a handle in the viewport. So we can take the transform in Y and do copy parameter. And then we can go over here and we can do paste relative reference into the fog height. Now as we increase this operator, you can see here, we can now control the height of our fog. And if we the fog height roll off, let's set that down to something a bit lower so we can create some nice ground fog here. And by adjusting the near and far clipping planes on your camera, you can sort of hold off the fog past the terrain. And we also have fog sun bloom. So if we actually had a light in the scene here, and let's cast a little bit of a warmish light on the scene. And we can see the exposure is already pretty high at 18. We can actually light the fog as well via these controls as well. So the fog sun plume and the fog intensity from the lights as well. So that's that. So this gives us a lot of localized control. We can have several of these operators in our scene. And inside of Solaris, it works quite well to add some fog to the Houdini GL viewport to see what it is that you're up to. One final option, as I said before, we do have volumetric fog as well, and you can control a lot of the quality settings on that option as well. So you can actually add some just broadband light scattering in your scene as well. And you can do above this. So you can have ground fog down below, and then you can have high volumetric fog on the top of your scene to control your scene. And of course, it's all lit. So really powerful tools with the fog, worthy of inclusion in this video. Now on to viewport state tools, number 6. Python viewport states are maturing quite a lot inside of Houdini 18.5, and we added something new, viewport state handles, and we've extended the drawables options as well in the viewport. Those are those things such as text and other decorations that you want to put in your tool. We've also done a lot of more work forward on that. And there's some of the tools that use that are, for instance, the polybevel and the labs box cutter SOP are using a lot of the new interactive Python states, as well as the measure SOP that we saw in the labs tool. And just to know that this is just the beginning for viewport workflow. So let's fire up Houdini and have a look and see how we can access these and what's the way forward to learn how to create these tools. Now inside of Houdini, let's take a look at how a couple of these Python states and the handles actually work. I'm going to add the test geometry pig head or the rubber toy, and dive inside. And we want to try the poly bevel out because we know that that got reworked for Houdini. So let's work a bit on the neck here. We want to add some edge loops on some primitive faces. So in here, let's do poly bevel. Select that, and now it's in the selection state, so we can actually select some polygons, and we got edges, points, or polygons. Let's choose polygons and use the A key to select a ribbon and then hit enter. Now we have a couple handles available to us. As you can see here, as we just simply do the left mouse button, we get a drawable on the screen, which is showing the distance, and we get a really nice indication as to what we're doing. And as well, the wheel will increase or decrease the number of divisions on our poly bevel. Really simple. If we right mouse on the handle tool on the left hand side, we can actually see the two handles that are currently bound to this particular tool, the distance. So we actually have two handles defined within Houdini, one called distance, one called divisions, and this particular tool is using those state handles in the viewport to do that. Really straightforward and easy to use. Now another one is the box cutter tool from the labs. So if you have labs installed in Houdini, you can do tab box cutter. And now with this particular tool, again, follow the state. All good tools should have a decent state. You can left click and drag on the geometry to create the cutting plane. Without letting go of the mouse, hold control and drag mouse to add depth. So let's try that. So we're going to actually draw in here, and then we're going to hold down the control key to drag up and down to create some depth. And when we're done, we just press A to stamp the shape and then draw another one. So it's working as advertised. And again, hold the control key, drag it down. And if we right mouse into different space, you can see geometry. We have the handles control also exposed in this particular tool, which are available over here. And a very straightforward state. And when you like that, you stamp that with A, and then you can keep on dragging and dropping your different areas. And you can even manipulate this handle to drive it in, and again control to drag down to sort of see where you're going. So, and there you go, and then A to stamp that shape again. So box cutter. Now let's take a look where these things are defined. If I right mouse on here, and if I go into the type properties for this particular asset, and we go into interactive, we can see here there's a viewer state that's defined on the node itself. Many of the default nodes that ship with Houdini will have the viewer state defined in a Python module in the installation build. But in the particular case with the labs tools, it's, the state is actually right in the viewport. And there's ways of creating these blank state, creating new states as well. And you can define how they sit in the shelf tool. There's the handles section now, which is new for Houdini 18, and you can actually create any handles you want, or you can actually, and all these handles available to us are installed inside of Houdini, and you can create your own handles as well. And that's the whole idea now. You can write your own handles and work with them interactively this way, and then bind them into your viewer state. So let's take a look at where those lie. I'm going to open up a new pane down at the bottom. I'm in technical. If you're in build, just either split your viewport pane or hijack one of the other panes. And if I press the plus button here, go to view new pane tab type, if I go into inspectors, we have the viewer state browser, which was available to us in Houdini 18 and has been expanded a bit. But we actually have the new pane tab, also called the viewer handle browser. And under file, we can actually create new handles. We can open a file of handles on disk. We can load a handle, and we can reload all the handles in case they've changed on disk. If we're doing edits on disk, we can force reload all the handles as well. And we can even debug the handles as well. There's filters on here for the types of handles. Some handles are generic to all states. But most are defined for specific states. We can see all the states that are related to the SOP, and there's the move tool handle, and there's a viewer state handle, and all those other handles. So let's pause for a bit, fire up Houdini, and actually take a look at a couple of the example files that ship with Houdini. So in this slide, I've listed a couple examples that we ship with Houdini. One of them is in packages in $HFS, which is an environment variable for the default Houdini scene, viewer handle demo, scenes, viewer handle demo. So I'm going to cut this string, and I'm going to paste it inside of my Houdini scene. But we're going to actually take a look at the move tool. and packages viewer. We'll take a look at the viewer handle, and then we'll take a look at the move tool. They're both in demo scenes. And the handle is actually installed in viewer handles move tool handle.py. Again, the handle is separate from Houdini. So let's take a look at the viewer handle intro and then move on from there. So now that we saw inside of this Houdini scene where we can actually see the viewer states and where we can actually install handles that are being used by the viewer state browser, we're now going to open up that scene file that I copied from that string, and let's do the viewer handle intro. And here we can actually see a nice example state where you can actually see what you're doing and how you're working with it. So basically locating and picking things, and this file is fully documented to help you get set up. And again, if we take a look at the viewer handle browser, we can see the view tool being used here, the move handle tool. And the second example file that we ship with would be the move tool. And that also uses the handle. So this is a very basic way of defining your own custom handle that you can then use to bind in any of your tools. And again, full help and examples to help you see how to bind these handles to these tools. If we right mouse on this and so we go in the move tool, if we go upstate, right mouse on this, and we go to the type properties on this. We can see here there's the viewer state, and we can actually see the handle that's being bound and referenced into this particular tool. And then the viewer state is calling that specific handle. Very, very simple example as to how to work with handles. And now we want to take a look at the edit operator type properties again, just to review on the handles. So you can actually open up the type properties, create a handle that you want, and then you can bind the handle off of disk to create it. And then you can reference that handle into your asset. And then finally, you can define your own default state to bind that handle to. And some of the other things that we have available to us as well are drawables. And drawables are available to you in the state as well. And one of the options you can use is a highlighter. For instance, this actually adds a highlighted glow around any of the objects that you have in your scene, whether or not it's active or not. You have that drawable available to you. And that goes along with all the other examples of drawing text in the viewport, giving hints, drawing histograms, and so on and so forth. So very, very powerful set of tools with the viewport states, the new handles that you can create, and also the drawables on the screen. One of the limitations we currently don't have is the ability to actually create handles via geometry, via SOPs yet. So right now you're still writing all of your handles via code at this point in time. Now we want to move on to modeling improvements in Houdini. We have a bunch of new SOPs, a host of modified SOPs, and also some really interesting things to key on our attribute paint and the brush hotkey revamp. So they've been, hotkeys have been revamped in those particular tools, trying to find a standard that frees up the middle mouse button. So for instance, Control Shift left mouse now is what's used to resize brushes and all of our brush type tools. And also we can take a look at some compile SOPs that have been added as the list continues to grow. So all the new SOPs, there's tons and tons of new SOPs available to us. Attribute adjust, float integer, those are pretty interesting because it shows a bit of a different look at how that we deal with attributes and trying to reduce the reliance on new users to learn Vex just a simple wrangle attributes. Mask by features SOP, path to form SOP, and all the KineFX SOPs, all the pyro sourcing SOPs that have been added. So a tremendous amount of SOPs have been added to the list. And number 7 leads me to these three guys, the attribute adjust integer, attribute adjust float, and attribute adjust vector. Those three SOPs are meant to make it easier for artists to work with attributes by type, and then we can provide operations by that type. So let's fire up Houdini and have a look at these three SOPs. So let's take a look at Houdini and all the different operators that we have available to create attributes to see how we finally got to the attribute adjust integer, float, and vector. Let's start with a lowly grid, and let's really increase that, and let's wire up all of these different all these different attribute type operators to the grid. Way back, we had this thing called the points op. By the way, you can still add that in a text port by just doing the old cd to grid object 1 and then using the op add point. We can actually op add point old, and you can create a point old. That would go all the way back to prisms. And some people would say all you needed was just a point sop and a grid, and you could animate the world. And one of the common things to do in that world was to add color, and we can actually put in here a rand function, $PT for the point number. And let's add an index to that, plus 1.001. And you can make a comfortable living teaching people how to use the point sop. It's not very artist friendly, but it gets you there. And so this is the lineage that we needed to run up to. And by the way, if you press the help, you can see a tremendous amount of example files and all the variables that you can use in here. So we progressed to that in the Vex world to the point operator, and it's pretty good, but now you need to know what type of attributes you want to work on. I guess from group, it might use points, it might not. Attribute class, sure points. But you'll notice that as I change the various different attribute types, we're presented with the exact same interface. So now it's on the artist to realize, am I on a point or in a vertex? But anyway, let's add random color. So we do the color, and over here we've sort of added these buggy bumpers around Vex wrangling behind the scenes, so we can actually do random. And you can see rand elm great. Still requires a certain level of understanding. Now for Vex expressions, this is about as hardcore as it gets. So you can do v at cd. Yes, you can omit the v because it's a known known attribute, but hey, I'm putting the v in there. And you can do rand and at pt num. So now you need to remember where pt num comes from. It is a global declared variable. It's not even documented on the attribute wrangle. You actually have to understand where that's coming from in the Vex world as declared attribute. Many times we teach people to put down a VOP wrangle and take a look at the global inputs. But anyway, once we do that, now we got random points. Now attribute create. That was another stab at doing this. So again, CD defaults to black, a lot more options. What class are we working with? Let's put down point, type float. It's a vector, I guess. And the value, so we can actually do a float in here. We can do 3 floats. And so you can actually create, you know, what it is that you want to do here, what precision. This one actually now starts to see you can actually declare the precision of the attribute as well, 18, 16, 32, 64. So you can now, and the value in here, again, you can use that same rand at pt num, but at least this time you don't need to declare it. And let's add an offset 1.001. And you'd argue that we're right back to where we were with the points up in terms of teachability. Yeah, it's is it getting any better and any worse? No, artists still needed to learn an awful lot about how to do that. And we can see it's not a float. You have to do a vector to see the color. And then we added attribute randomize, which was, again, what do you want to work on? Points, CD. It defaults to CD, yay. And now you can choose what type of noise you want to do. Again, let's do constant value, not random. Let's do 2 values. Let's do uniform discrete. And now you can change, at least you can change the minimum and maximum range now. Again, loose collection of where to go. And of course, attribute noise, a dedicated operator for simply adding noise again. And you know, you can actually add animation to this. So you can scrub and you can see your noise animated. And then there's finally attribute remap, which allows us to, it doesn't even show us the attribute. So it's CD, we know that, and the original name. And let's wire that into there. And now we can remap these ranges again. So we got some of the functionality that we got with the attribute randomize. And we can actually apply a ramp to this, and we can actually do some really cool thresholding. So all attempts at trying to minimize the amount of work that an artist needs to do. So what did we do? We have the attribute adjust integer, attribute adjust float, and attribute adjust vector. So another stab at this whole world of attributes. So we have attribute adjust integer, and the attribute name, we can use CD, we can pick on CD, or we can use variant, and we actually have a nice visualizer now. So all the modern trappings that we have in SOPs available to us in 18.5. And we can choose what class, point, vertex, primitive, or detail, but the attribute adjust integer, it's really only creating integer attributes. So let's actually take a look at what it is that we're working with. So we go into the spreadsheet, and we can see variant. To be honest, all attributes on point attributes are of type float at the end of the day, but they can have signatures of int to optimize them through the SOPs. And then we can now do random. So now all the options available to us in integer are finally presented in a single interface. So hopefully these are your one-stop attribute mucking operators. So all of this whole lineage and all of the whole mix of assets and attributes that we have, that we've created over the years, hopefully will be replated entirely by these three. So if you're a new artist into Houdini, or you're an existing TD wanting to teach new artists, stick to these three. They're great tours of how to do work, and then show them wrangling if they even want to use it, because you can go so far with how far you can go with this. So you can actually do positive values, you can create amplitude ramps, you can do custom elements to change the seeds, you can even enable post-processing where you can actually blend attributes in and out, you can change the length scale, all kinds of different ways of working on these attributes. And attribute adjust float, again, in this case we're doing it on p-scale. We can visualize the p-scale in the viewport. It's a constant value. We can change that constant value from 0 to 1. We can also randomize this, and again, like we saw before, we can threshold the value. Let's leave it, let's say we were scattering some trees on there, we want a value of 3. This adaptive visualizer will adapt to full range for us if we wanted to. And the step size, we can even apply stepping to this, so thresholding on the attribute, which is really cool. And again, post-process, we can change the minimum and the maximum value of all of this, so we can threshold this away as well. So lots of control in the attribute adjust float. And of course, we always have, you still have to teach new users how to use the control key, or to right mouse on the operator to actually get or middle mouse on it to get that, or the control key, or to use the halo rings if you want to wait for the halo to show up. You can actually see show modifications to attributes. So we did a tremendous amount of work trying to simplify this for the artist as well, including getting draw visualizers right from here as well. So you can actually use the visualizers right from the attributes. And finally, to complete this attribute adjust vector. So we were picking on V, but let's, and the one thing that's interesting about attribute adjust vector is it isn't the best with color, and we know that. It came out in testing. So we might actually have one specific just for color, or the color SOP could see a rework. And actually, that's one that I should have added as a way of, and let's shift hold down that and drag a copy wire to the color. We could have done that, but again, this one needs a rewrite because you're stuck with the color, having to wire it into one of these guys again to get it to work. So we know we got a bit more work to do on the attribute adjust vector, but in this case we're doing velocities, and now it's specifically designed to do all kinds of fanning operations on vectors themselves, directions and lengths. We can do random, we can add just noise, we can adjust the amplitude, again the element size for the actual noise itself, we can lower that down if we want to create nice wavy noise through our field. We can apply warping. So specific tools, cutting edge tools for dealing with vertices are now available to that. So to recap, teaching new users or yourself, if you just want to start mucking with attributes and not have to worry about any of it, best of breed, attribute adjust integer, attribute adjust float, and attribute adjust vector. And color, yeah, we'll see. And so that's a great recap on that. And to complete the whole presentation, we have compile SOPs that are added as we continue to take more and more SOPs and we verify them so they can be used in compile blocks. Solaris has seen a lot of improvements. I definitely want to do a separate video on all the power that we have with vex array and support and wrangle lops and vops. Tremendous amount of control. Finally have arrays. And that's extraordinarily fast now. So we can actually pack attributes into arrays and do some really heavy lifting in Vex. USD dynamic payloads. My gosh, we finally have USD supporting digital assets, and we actually have the HDA dynamic payload lop where you can reference an HDA. It's ideally suited for hair and fur, but there's an example where you can even just generate spheres at render time. And it's a way of getting geometry into the render engine as a payload. And yes, it will use an engine license for certain amounts of geometry creation. And command line rendering, definitely want to cover that one as well. We can now offer Python commands for doing last-minute injection of USD into Husk command line rendering. For instance, turn all objects that contain pig heads or whatever you want can be easily added at the command line when you're rendering via Husk now. And KineFX, which you're probably going to see lots of. I definitely want to have my own take on that. Dynamics, as we saw before, looking at all the atomic subs that we have, and finally the PDG. Definitely want to have a look at all the improvements inside of the PDG, including some things that are outside of that, including the data layer, partition attribute improvements, work item generation parameter, a lot of housekeeping work and a lot more sophistication in the cooking and PDG graphs now. And finally, there's the web server module. Definitely check this out. It's worth seeing how you can embed Houdini commands inside of a web server, and then you can feed that into any Houdini request, any running Houdini process. Very, very powerful stuff. So thank you very much for hanging on for this quick tour of Houdini 18.5. Enjoy all the features. It's a deep, deep release with a lot of meaningful tools and with a lot of thought moving forward as to how we're going to deal with interactive tools and the artists, as well as keeping the high-end TDs happy. Thank you very much. Bye.
All right, next up we've got Mihnea Stoica. Hey, welcome.
Hey, good to be here. Thank you for having me.
Give us a little background on yourself.
Right, so I've been studying at the Breda University of Applied Sciences in Breda, the Netherlands, and I actually just recently graduated. And that's where I was kind of first introduced to Houdini in my first year there. And actually ended up spending my last year of university interning for SideFX. So I did my first half in LA with the games team, and my second half from home in Romania with the Toronto team. And that year I mostly spent working with the new KineFX toolset. And now I work as a character TD for SideFX.
Right on. So what's this presentation going to be about today?
So today we will look at mainly the new KineFX package, and to be more specific, we will go through the cleanup tools. So you have stuff like stabilized join, turn up adaptation, reverse foot, collect geometry. So sort of looking at after the retargeting or after the initial animation has been done, what can we do with it to make sure we polish it a bit further and get us closer to that final production result.
Excellent. Well, let's jump in.
All right. So our presentation for today is called KineFX Animation Cleanup Tools. And we're going to talk about a tool set for KineFX that can help with cleaning up some of the retargeting motion or even keyframe motion that we have. So as a short overview on what to expect from this tool set, we have here a walking animation of our character Eric, and we see there are a couple of issues with it. To visualize these problems a bit better, here is a zoomed version of our character Eric, and let's start and isolate each one by one. So here we see the clavicles are kind of sunken down, look unnatural. Here we see that we have some offset from the floor to the actual foot as he steps. And then also we've got some sliding going on. So these are all things that we want to address and that we hardly or usually cannot address in the retargeting process. This is the result after we've applied some of the cleanup steps that we're going to discuss today. So we see the sliding is gone, the offset is gone, and the clavicles look more natural. The tool set that we'll go over today consists of 5 nodes. We have 2 VOPs and 3 nodes. Let's kick it off with the first one, realistic shoulder VOP. So one scenario where you will want to use a node like this is when you have an animation that doesn't actually require the hands to lift too much, but it's just from the retarget directly we get this weird like downward look as we see in the overview. We don't like this. Using the realistic shoulder node, by limiting the clavicle downward rotation, we can get a much nicer and cleaner result. We like this. Next up, here is a version with an animation that actually has the hands go up over time. So here it's doing some weird shearing motion. And we see that the angle between the shoulder and the arm also looks kind of rough and unnatural. So we don't like this, and if we can correct it in the retargeting, perfect. But if we cannot, then the realistic shoulder will come in and help. So here we see this is exactly what we want. Now the clavicles follow the shoulders nicely, and it gives Eric a much more nicer animation. Now let's take an actual closer look at the node itself and see how we could set up something like that ourselves. So here we have a very complicated animation for Eric, where he's rotating his arm 90 degrees up. And we want to rotate his clavicle as well to make this look a bit better. So let's start by dropping down in the rig attribute up. Click on it and let's fire the Python state. Now we want to disable the output and we want to disable the second input. We only want to see what's in our main input. And while we're at it, let's also connect our deform pose in the second input, the same as our first example had. Now we can go inside and we can type realistic shoulder. This will drop us the VUP node, and we can start to look over the inputs and parameters. The first one is the file rest, which is already set to second input, so this is already done. The next four are some points that the node needs. So we have clavicle, shoulder, arm, and hand. So let's go ahead and start to grab these one by one. Clavicle, shoulder, lower arm, and hand. I'm holding shift to select all, and then I'm just dragging and dropping into the parameter view here, network view. So now if we get each point individually, we can plug them into the node. Perfect, that's done. Next up, we've got look at clavicle axis and look up clavicle axis. So what these are? Rotation axes of the clavicle that basically tells the node how to rotate the clavicle to match the arm. So since we're in the state already, we can right click and display joint axes. And this shows us for the clavicle all the three axes. The look at is the axis pointing at the shoulder joint. So in our case, it would be positive Z. And the look up is the one that's pointing towards the pole vector of the arm, which in our case would be that way. So the way the shoulder is supposed to, the elbow is supposed to be pointing at. So in our case is positive Y. Now if we wanted to specify these, we can put down a constant node here, set this to a vector, and let's set our look at axis to be positive Z. You don't really have to specify them unless you get bad results, because they are both automatically computed inside. The same goes for the points. If you specify the clavicle point, the other three will be computed using a very simple heuristic method. So it's basically just looking at the parent of the clavicle and then the parent of that and the parent of that. But in scenarios like this one, where we've got a twist joint in between and their point number is in order, so we start at, like if this were started at 0, 1, 2, 3, 4, this method won't really work, so we have to specify each one individually, but the axes will work, so look up we don't need to specify. Next up, we've got rotation threshold, propagate rotation, hand pinning, limit clavicle downward, and active. To start at the bottom, active just tells the node whether or not to set the transforms on the joints or just output them here. So if you want to do something else with them later down, you don't have to actually set them in the realistic shoulder. Limit clavicle downward, as was shown in the first example, is basically matching the rotation of the clavicle to the one in the rest pose. For our example, we don't actually need this, so we can disable that. And then we've got rotation threshold, propagate rotation, and hand pinning. The hand pinning, let's go ahead and create a parameter for it so we can see it a bit better what it's doing. Plug that in. And then let's also make a parameter for propagate rotation as well, so we can visualize the results a bit better. Rotation threshold is the angle between the arm and the body, above which to start cranking up that clavicle rotation. So it's basically the threshold. When that threshold is met, so when the angle gets over this rotation threshold value, the clavicle can start to rotate. And then the other two, so let's come outside here, we can exit the state. So we've got parm2, which is our propagate rotation. So if we start to crank this, we see our clavicle starting to rotate. So this basically is a blend between don't rotate the clavicle at all and rotate the clavicle as much as possible, which is dependent on the rotation threshold. Usually somewhere 30%, 40% of the way there is something that looks quite well. And then for the hand pin, if we take a closer look at the hand, we see that it also gets shifted upwards. So the whole arm basically gets rotated around that clavicle upwards. But in certain scenarios, we might want to preserve the position of that hand to where it was in the original input. And for those occasions, we can blend in the hand pinning, which will make sure to put the hand exactly where it was before we apply the realistic shoulder. So now if we check against the original input, we see that the hand doesn't move an inch. And this is the core of the realistic shoulder node. As a takeaway, the most important thing to remember here is you should always try, if you have data, so if you have data in the source animation that you're using for the clavicles, try and use that before looking at this node, because always using data that comes from our source usually will be better and cleaner than creating new data ourselves. This node basically generates data for the clavicle from scratch. So it should only be used when there's no real other way, or we can't use the data that we have. Moving on, let's talk about the reverse foot. So this node basically allows us to rotate the foot of our character around specific pivots. So we can do stuff like foot roll, pivots, foot lifts, etc. So let's take a look at the node itself. We have here a very basic setup where we actually got our character Eric. We're offsetting the knees so that we get a proper IK solve with no problems in the Riga trip VOP, and then a bone deform. So let's drop down our reverse foot node upstream of the rig pose. And let's start by filling in the required joints. So we're going to start by selecting the upper leg, knee, ankle, and then the ball joint. We have no toe joints, so leaving that field empty is going to be perfectly fine. Next up, let's also select the pelvis joint just to keep everything consistent. Now, once this is set up, we can display what we've got, and we can see we've got two little markers down at the bottom. Now, the two markers that we can see are the heel and the ball, because these are the only joints that we specify, so there's no toe joint. One way to position them properly would be to template our skin, come down to the toe here, and start to move them until we sort of get the position that we want. However, this can take quite some time, and there's a way simpler and faster method. So let's just go ahead and nuke that. What we can do is we can take the skin and the rest, plug them into the inputs, and that gives us the result already. It's basically projecting the markers onto the skin, and now we're getting exactly what we would expect. If we template this, we see they're nicely aligned at the heel, toe, ball, outer and inner. All right, now that's set up, let's quickly talk about the mode here. So we're currently set on create markers and solve reverse foot, which means we want to create the markers and also do the reverse foot setup in the same node. We can also just create the markers and then also only solve. The solve, of course, will not work unless you have some markers in the stream. We will get over the why we can sort of have different nodes or create and then solve in separate nodes when we talk about the stabilized joint. For now, we're going to keep it to create markers and solve reverse foot. And now under the offset markers, roll and advanced here, we've got our options for actually using this node to give us the setup that we need. So if we look at the roll, we can start to see as we start to influence the parameter, we get this nice foot roll. Then under the advanced, we've got very specific controls for each marker. So let's zoom in here a bit. We've got heel lift, so lifting by the heel, ball lift, toe. We can pivot by the heel, by the ball, by the toe, and we can twist inwards or outwards. Another approach is to create our own set of custom markers and then solve those using the reverse foot VOP. This can be quite useful if the SOP does not give you the results you're looking for. So let's go ahead and create one custom marker for this example using the skeleton SOP. We can put the skeleton SOP down, enter the state. Let's come here and make one joint at Eric's heel. You can click over there. Let's name this heel marker R. Let's change this to modify and display all handle. If we go to side view, we can move it down a little bit and maybe a bit to the back as well. All right, so now we have our custom marker in the back of Eric's foot. We've got the rig pose as shown before, where we're just sort of offsetting the knees, and then we found the IK solve in the rig attrib VOP. Since we already have the rig attrib VOP set up for us, let's just go inside and add our reverse foot option here. So let's type reverse foot. That gives us the VOP. And at first it might look scary because there's so many inputs, but really all of those are just the same sort of inputs that the SOP takes. So we've got the joints that we're interested in, ankle, ball, toe, all the pivots that we can add, then some axes for the pivots that we can specify, and then last but not least, all of the options that we also have under the advanced tab and under the role tab on the SOP. So for this example, we only have a single marker. So we don't really have to add all of those in. Grab this marker that we just created and bring it in the VOP. So if we can drag and drop, there it is. And now let's start plugging things into the node. So we've got ankle X form, which we can take from our VOP here. We've got the ball X form. Plug that there. There's no toe. And we have our heel pivot X form, like this. Axis-wise, we can check if they are correct. So if we come to the state, we want the front axis, which should be supposed to be positive Z, that's correct. And our side axis, which is supposed to be positive X, so this is not correct. So we can change this to be positive X. Next up, all of the other options. We can just make one parameter here. And we can connect this to our heel pivot, something that will work with the current marker that we set up. Once this is set up, we can go to the outputs and start to plug the outputs properly so that we can actually see the result. So we can take the ankle and connect this to the goal of the two-bone IK. So we're basically taking the foot, running it through the reverse foot, and then solving the IK. And we can also take the ball here and just set the ball on the first input. Once this is done, we can come out of the rig attrib VOP, display Eric's skin again. And now if we start to mess with the parameter, we see we are getting the pivot. And this is the core of the reverse foot node. As a takeaway, this node can be used anywhere in our hierarchy. We can use it on a static character to create some animation using the options that we've got, or we can use it after a retarget step. Then the markers will nicely follow the animation and give us access to some pivots that we can rotate the foot around to clean up the motion. Next up, let's talk about the stabilized joint. So here is an example where we've got some foot sliding. So basically what we've shown in the overview, and we already determined we don't really like this, we need to get rid of it. This is where the stabilized joint kicks in. We see here, we are basically we're using that node, and the sliding disappears. So let's take a look at the node itself. We have here a basic setup of Eric and a bad walking animation. We see the feet are completely not lined up with the surface, also offsetted a little, and floaty. So how we would go about fixing this? We have an IK setup where we just have a set of IK chains for the feet, a rig pose for the pelvis, which we might need to slightly push down to avoid any overstretching. And then here is a skeleton blend for the ball joints, because we will want to also add a bit of foot roll in the ball here using the stabilized joint. And the IK doesn't actually transfer the motion for the drivers back to the main input for other joints than the ones selected in the chain. So let's start by dropping down a stabilized joint. Select the main target in, and this over there. And now let's select for our joint group, let's select the ankle joints. So we're going to select both of these, hit enter. So the node comes by default with the max position change option turned on, which will use an automatic computation of when to stabilize the selected joint. We see when the joint is red, it's being stabilized, and when it's green, it's not stabilized. However, we are dealing with a fairly short frame range here, so we want to go ahead and do this ourselves. Have a bit more control over the stabilization itself. Before we start stabilizing anything though, what I want to look at is this distance to geometry option, which kind of does the same idea, where it's just looking at the distance between the joint and the geometry, which, another note, is the geometry comes from the third input, and as we can see, ours is empty. If it's empty, it's going to use the grid world origin, so basically just the origin of the world, and with a normal of positive y, so the most default ground floor you can think of. Or we can just plug this in if we really wanted to, maybe give it a normal attribute as well, and that's going to be the same idea. So this. Right, so this is another automatic option for stabilizing the joints when it's within that distance. Now, we don't want to use any automatic options, as I just mentioned before. So let's set this to something real high, and then check use distance to compute intersections only. This means that now we're not actually using that to lock the joints, we're only using that to compute intersections that will help us when we want to match the orientation. So down here, we've got the option for matching the orientation. We want to match before contact. So before we actually stabilize the joint, we want to start blending into that rotation of our surface. Orientation attribute is normal, we just define it here. The custom joint axis, you might want to specify if the result you're getting from the automatic computation isn't right, but for Eric, it's going to work just fine. And the direction, we can set this to -y. Because we only want to intersect in that direction. So now if you come back to the override section where we actually can start to stabilize it by hand, we're in the state, as we can see. So we can start with the right foot. We can select it, play through the timeline as well, and let's say we want at about like frame 1 to already start with it being locked. So we come here at the top, we can select both position and rotation to lock. Blend in and blend out frames, the default should be fine here. We can start the lock. And we see as we did that, the foot already snapped to match the orientation of our ground. And then we can go to about, let's say, frame 5 or something and end the lock. So now we've got, as we reach frame 5, we're going to start to blend out both position and orientation. Now we get a bit of a floating feet here. Floating foot, because the I key chains is dragging it after. So let's lower the pelvis a little bit here. Something like this. So now we see we've got our foot nicely and stable. Let's repeat the process for the other one as well. So we can sort of come through here and look at when we want the foot to be planted. So let's say here, right click, start lock. That's going to lock it into place. Then we can move through the timeline. Now it can help us if we only want to visualize the stabilized joint. Here we see that we've got a guide geometry basically that shows us the original motion, so we can easy to decide when we want to release. So let's say roughly about here we can end the lock. So then over a period of 2 frames it's going to go back to where it was. Back to the skin, and we see we've got a nice step there, and then it blends out. And let's do one more. About here, start lock. And we want to lift it up, maybe here. Maybe we can come to our entries here, and if there's something we see we don't like, we can change it here directly. Or if we want, we can, for example, just go to frame 29 end lock, and that's going to also update the entries correctly. So something like this looks about right, as we make sure we don't get any floaty feet, and by making sure that the orientation matches, we see we've also got rid of any offsets. If, however, we still have some offsets, we can either just offset it using a rig pose downstream, or we can play with the enable snapping option, which will snap that joint exactly on the surface of the geometry. And we can do a bit of an offset to give us the right. Perfect. There we go. So now basically we've got 100% snapping onto the terrain. It's exactly where it should be, and it's also matching the orientation. Next up, let's go ahead and chain up another stabilized joint, just to try and get a bit of that foot roll happening. Because right now we see that the foot remains very straight, and it just sort of floats through the ground. So let's connect our inputs. Now, one thing to mention is that we want to also connect the motion clip. The motion clip output holds all of the modifications that we've done on the animation as well. So now both of our outputs hold modifications. But this node computes a motion clip inside to work on. And if you want to chain multiple, then just chaining the motion clip can save a bit of computation power. So let's chain up another one. Put the output there, and also make sure we have this set to our skeleton blend here. And now we want to set the joint group to be the ball joints. Select both of them. We don't want any automatic either. What we want to do now, we want to lock the rotation of the ball joint right when the foot lifts. So we get a bit of a foot roll type of thing. So let's fire the state. And we can go through this. Now we see that the ball starts in a kind of a weird position up here, as in it starts to sort of go down, and it seems like we're locking the ankle here, but the ball doesn't actually do anything, just sort of minds its own business. What we can do is we can come back to our ankle stabilization, and we can update children transforms, and this will make sure that all the children of the stabilized node also gets stabilized and inherit the stabilization from the parent. So now we have it nice and clean. So we can come up here and set this to rotation only. Select our ball, and let's say here we want to start the lock. 1, 2 frames perhaps. Maybe here we want to end the lock, or maybe one before, something like this. So now we have a step. This does not rotate, so sort of gives us a foot lift, and then it blends out of it. Let's do the same for the other one. Want to lock here and unlock roughly maybe one before, something like this. Now you see it already starts to sort of come up fairly soon, so maybe we can play a bit with when this gets released. So let's set this to like 18 and maybe lower the pelvis a little. So we have two stabilized joints chained up together, which sort of cleans up the original motion, gives us a nice flat foot on the ground, also a bit of a foot lift in the mix, and it's all of a sudden it starts to look a lot better. Now, this method of giving us a semi-decent foot roll is acceptable, but it's obviously not going to produce super incredible results. As we see here, we've got a bit of a movement in the ball there. Plus, it's okay, but depending on your shot, you might want a bit more options. We're going to take a look at a better way to achieve this kind of thing in the next slides. So in this example here, we see that if we play the motion, we get a smoother and better result overall for the feet. So if we zoom in a bit here, we see as the foot lifts off the ground, we sort of get this nice foot lift that's way more stable than what we had before. We have no floating feet, no floating toes, no anything. A bit of protrusion here from the way the animation was set, but this is easily fixable with a rig pose if necessary. And really, it's more about experimenting with the combination of stabilized joint and reverse foot, because the reverse foot gives you access to a couple of markers that you can then use to stabilize or rotate the ankle around. So this can allows us to do some interesting things. So let's break down this example really quickly. The first stabilized joint is nothing too special. It's the same as we did before, where we just stabilize the ankle. Then we are building the markers for a reverse foot setup for the two legs. And then the next stabilized joint, what it's doing is it stabilizes the position and rotation of the toe markers. And the reason for this, if we do this, is because we want to avoid exactly this type of behavior, where the rotation of the ankle makes the toes kind of go downwards into the ground. So if we do this, we see that now we're getting this nice foot lift right here. And then the last stabilized joint that we have here is acting on the ball marker. So if we fire the state on that marker right there in the middle, and its purpose is to basically limit the extension of the leg. So we can see it better here. If we disable this, we see as we get this nice foot lift, this kind of deforms a bit because we don't really get proper orientations to match for what we've just planted. But if we also make sure we lock the ball, we get a nicer and cleaner result because the ball also gets like stuck to the ground, and then we get the lift off right here. And all the way at the end, we just have another reverse foot set to solve to basically calculate everything that we're doing to the markers and put it back onto the main foot joints. And that's it basically. So playing with the combination of reverse foot, markers, and stabilized joint or rig post to rotate them around can lead to some quite powerful results, even if your source motion doesn't have any like toe rotations or so on and so forth. As a takeaway, using the stabilized joint to plant the feet or any other joint really can be really powerful, especially after a retargeting that can lead to some slidings. But also using the stabilized joint in combination with the reverse foot gives us access to a much more powerful foot plant, because all of a sudden we now have access to all the markers generated by the reverse foot, and we can plant each marker separately. Next up, let's talk about the adapt to terrain. So this node is some sort of one foot into the area of cleanup and the rest of the body in the area of producing new animation roughly, or giving you a good pace at that. Here we have a simple walk animation for Eric that we also see in the overview. And now we want to take that animation and adapt it to such a terrain that we see here. So this node comes into play to basically generate this new motion for us. So let's take a look at the node itself. We have here a simple example of our character Eric and a simple walking animation. We see that it's a flat walk. And then we have a slope here that we would like our character to climb on. So let's start by dropping down the adapt to terrain node. Plug in the proper input. And now let's take a look at the parameter interface. So the most important part to set this up is to come here under main and add in the hip or hips if you have a quadruped. So we can select the pelvis. And then for the lower limbs, we want both feet. So we can do knee, ankle, and then the toe. And then let's do one more. Knee, ankle, and toe. All right. And now already, if we start to play this, we see absolutely nothing is happening. And the reason for this is because our terrain input is empty. So if we actually connect our terrain to the terrain input, and now we play this, we see we are getting something. After in the initial setup, we still have a couple of options that we can play with. So if we come here to the advanced tab, we see there are a few toggles that we can play with. So the first one would be the hip lean range. If we enable this, as we start to play again, we see that Eric now is sort of bending forwards as he's climbing the slope, which gives him a bit more of a natural look while on the angled surface. Now, a small issue would be that we see that the way it transitions from one to the other, so from the straight spine to the bent over spine, it's kind of sudden. So to fix that, we can check max rotation per frame, and that will limit how much the spine can rotate, or the pelvis can rotate to 2 degrees. So now if we play, we see we get a bit more of a blend in to the rotation. Now to the leg options, we have the enable ankle to toe lookat enabled by default. So what that's going to do is it's going to make sure that the ankle rotates to match where the toe is being projected. So if we disable this, we see that we are getting kind of a weird step. So we still keep our flat step, but if we enable this, we still will get a more natural looking step on the surface here. Something to note is that if your axis, that's the angle axis that's pointing at the toe, doesn't get computed correctly, we can come back here to the main tab and change our axis to something else. We can do so for each lower limb. And then another option that I want to look at is the enable terrain-based foot lift. So this option, if we just sort of quickly read the help card, enable lifting the feet based on the terrain slope. So we see that right now the step comes fairly close to the slope itself, because it's still using the same, we're still using the data that we have, which is a flat walk. And this, in certain scenarios like this one, can look a bit weird. We want the foot to go a bit higher, so the arc a bit higher when he steps uphill. So if we enable this, we see we get an error, and we have here a position stabilization attribute, p stabilize data, which we don't have, so that's what the error is there for. And to get that attribute, we can use the stabilize joint node. So if we plug this upstream, give it a sec, there we go. Let's come here to the joint group and select our ankle joints. And leaving this to automatic, so max position change will provide a good enough result for our scenario right here. And we want to set this to output stabilization attributes. And then we can also connect a motion clip if we want to. So one by one, the stabilized joints will now basically plant the feet. And if you output that attribute, we see here p stabilize data, are basically converting the idea of foot pinning or foot plant to an attribute. That's if we look at our geometry spreadsheet here, we see that here, for example, it's blending into 1, so now it's planted, and then it's blending out back to 0, so now it's loose again. So this is the data that the adaptive terrain is going to use to determine where each step is, so that it knows that the in-between arc needs to be lifted. And then the motion clip input we're just adding in for convenience, so don't have to generate any one inside the adaptive terrain. So now if we display this node again, we see the error disappears. And if we play through, we see we get this nice foot lift. From here, goes up and down. Whereas before, we had something like this. And we can change the blend if we want to lift it higher or lower. All right. Now that we're done with the Advanced tab, we can go over to the Solve tab. And this tab is fairly important because it basically just connects to a full body IK inside the adaptive terrain. And messing with these attributes here will improve a little the solve itself. So let's crank the iterations up to 100. Let's crank the damping as well to sort of get rid of that leg overextension pop there. And now we see we get something that looks very sensible. For configurations, if we need any, we can add them here. The default configurations basically set the feet to something quite high, the pelvis to 1, and also it's going to limit the rotation on the knees to only be in the correct leg plane. For our example though, we see that we don't really get what we're looking for, mainly because something quite high on the feet will make the character jitter a bit, since it's already kind of a stretch. So we can kill both of these and this as well, and just leave the knee rotation, and that will give us a nice result. One last note is that if we don't want to solve here, so if we disable the solve, this will basically bypass the actual full body IK inside. And what this allows us to do is it gives us access to motion trails here. Ignore the craziness that's happening here, is because we don't have terrain. So this represents our pelvis and ankles and toes, and the way they have been rayed down to the terrain. So now we can basically use these if we want outside of the node, manipulate them even further. So we can do something like a soft transform perhaps. Can select a point here, increase the weight a bit and lift that up there. So now we have this on the pelvis. We can move this a bit down. And now if we drop down a full body IK, we drop that here. And then we want to turn these motion trails into something time dependent so that we can also like plug into the drivers of the full body IK. The way we can do that is either we can take the motion clip from upstream from here and do a motion clip update to update that motion clip and then motion clip evaluate. Or we can just put down a blast node like this. And here under group, we can set it to points. So the expression we want to add here is at time equals time being an attribute that we can find on each point of the motion trail. So it's basically storing the time dependency as an attribute in that motion trail. This equals our current frame minus 1 because we're dealing with time, divided by the current frame range of our scene. Now if we delete non-selected, we see we've got the time dependent back in the game. And we can plug this to the full body IK here, set this to match by attribute name, and then bone deform it. And now we can play with our soft transform as we see fit. And as we play the motion, we see we're getting the results. So this can be a nice way to take what the adaptive terrain is giving us, refine it further using the subtools, and then solve ourselves a bit later on using a full body IK. And of course here we can configure iterations, so on and so forth, to match what we had before. And this is the core of the adaptive terrain node. As a takeaway, keep in mind that this node should be used mainly as a base, because what the node's doing is it's taking an animation and it's trying to ray that or produce a new animation from the base one. Usually if we, for example, walk on a flat surface, our walk will be quite a lot different than if you want to walk uphill. So this node is supposed to give you a solid base in terms of locomotion and initial raying that can get you started into cleaning it up further and refine it so you can get to the actual desired result. And last but not least, the collide geometry VOP. So let's take a look at the node itself. We have here our character Eric between two walls, and he's about to be squashed. And we want to collide his hands with the wall. So as the wall approaches, he basically like pushes against the wall a little. So the setup we have prepared here is a simple IK change setup for the hands, as well as offsetting the elbows to improve the solve quality. And we want to collide the hands. So let's go ahead and drop down the Retargeting VOP. Fire the state. We want to disable the output. Go in. And let's get both hand joints. Bring them inside here. You can start with the right one. And then we want to do the collide geometry VOP. Drop it down. And let's also do the set point transform and connect these three together. So we have everything prepared. Now looking at the collide geometry VOP, the first thing that we can see is that we need a geometry file. So we need to point at the actual geometry that we're about to use. We can do an operator path, or we can also just put into an input. Now this will throw an error because the Retargeting VOP computes the transforms for all the inputs. And of course our walls are not related to KineFX skeletons in any way. So we have to disable the transforms from the second input, and that's going to bring everything back to working. Now let's select this to the second input. The type can be primitives or points. We are good with primitives for now. The attribute is normal, we have normals. The direction for our right hand is going to be -x. If we leave everything at 0, that means all axes, which in this case won't make a difference, but this is just for convenience sake. And then let's also match orientation. We want to match before contact. And for the joint axis to orient, so basically which axis of the hand joint we want to orient to the normal of the surface. If everything's zeroed out, it's going to be automatically computed. But for this example, we need to tweak it a little bit to get exactly the result that we're looking for. So I have some numbers here. Now if we come outside and we check the result, we have a nice collision with the hand. Let's go ahead and do the same for the left hand as well. So plug in the X form, bring in the set point transforms here, this, and then this. Also make sure we set this to be positive X now. And now if we play, we see Eric pushing against the wall as the ball approaches. And this is the core of the Collide GeoNode. As a takeaway, the Collide geometry VOP can be used real time. So we can have a rig pose upstream with the Collide geometry downstream, and we can, in the viewport directly, play with it and see how it influences our result. Another little trick that you can do is you can also try to use this on the skeleton and have it collide with the skin of the character, and this way avoid any intersections that might result from your retargeting. Thank you very much for your attention. If there are any questions or you have any issues, don't hesitate to shoot me an email. Cheers.
All right, next up we've got Bogdan, who's going to do a presentation for us, and Paul, who's going to translate this intro. Welcome, guys.
Hi. Great.
So let's start with a little background on yourself.
Я художник по персонажам из Украины и риггер.
I'm a freelancer, character artist and rigger from Ukraine.
Как раз из-за персонажки заинтересовался Houdini, когда увидел видео Дениса Козлова, и он как раз демонстрировал там процедурных существ.
I've got interested in Houdini 3 years ago after when I saw video with procedural characters from Denis Kozlov.
И на сегодняшний день Houdini является моим основным софтом для персонажки.
And today Houdini is my main tool for character production.
Excellent. So what's this presentation today going to be about?
Я покажу ретаргетинг анимации на своего персонажа, точнее не своего персонажа, а на риг персонажа из Mixama.
My presentation is about Mixama character animation retargeting.
Excellent. Well, let's get started.
На этом видео демонстрировалась новая возможность ретаргета в Houdini. Конечно же, да, и до этого мы могли использовать инструменты CHOP для перенацеливания анимации, но, на мой взгляд, это довольно нетривиальная задача, особенно если мы говорим о персонажном риге, поскольку нам необходимо найти и переименовать большое количество каналов, и это достаточно непросто автоматизировать. И более того, таргет и source-скелет, скорее всего, у вас не будут совпадать по ориентации костей, и вот работать с последним в объектном контексте действительно затруднительно. Чего уже не скажешь о SOAP-контексте. В частности, KineFX инструментах, они нам сейчас дают отличный интерфейс для решения этой задачи. Давайте, чтобы не быть голословным, я уже перейду в Houdini, и мы соберем что-то похожее вместе. Для начала мне понадобится какой-нибудь риг. У меня такой есть. Это максимально простой риг, тут ничего нет особенного. Я акцентировать на этом внимание не буду. И сразу открою его в SOAP-контексте. Назову Retarget. И чтобы открыть, мне понадобится нода сцен Character Import. Так, отлично. Выберу сам осет. И также оставлю только геометрию и кости. Хорошо, теперь я сразу добавлю Bone Deformer. Также хочу обратить внимание, что с первого входа мы получаем геометрию, со второго входа Capture Pose и с третьего входа мы получим сам скелет. Так, давайте сразу откроем и анимацию. У меня есть несколько анимаций из сайта Mixama. Я сейчас выберу любую совершенно. Вот эта анимация. Она немного имеет другой размер, но это не страшно. Так, и давайте сейчас посмотрим сразу на скелет. Я выберу ноду скелетон. Вот наш скелет. Я хочу сразу обратить внимание на то, что у нас сейчас отсутствует тут иерархия. И дело в том, что это будет происходить в двух случаях. Если в вашем риге вы используете chop parent, либо просто непрямую иерархию, как в данном случае. Давайте сразу посмотрим на это. И сразу можем обратить внимание, что parent к нулю, а не в прямой иерархии между костями. Это же касается и тазовой кости. Хорошо. Теперь мне необходимо это исправить. Нода скелетон это как раз хорошо умеет делать. И мне необходимо выбрать HIVE и mods modify поменяю на create через enter. Прикреплю к основной кости split. Повторю это же слева. А также я помню, что у меня эта же проблема возникает и с тазовой костью. Чтобы убедиться в этом, продебажу через rigpost. Хорошо, выберу pelvis bone. И как раз да, мы видим, что нету иерархии. Я выберу hips bone и прикреплю уже к pelvis. Хорошо, все. Я для себя также укажу, что я исправил тут иерархию. Мне сейчас потребуется снова нода скелетон. Она мне как раз поможет избавиться от всех джойнтов, которые я не планирую в дальнейшем использовать для ретаргета. Если уж проще сказать, то я сделаю что-то наподобие того, что мы получаем с миксама. Двойным кликом я могу выбирать целую цепочку и удалять через delete. Теперь я переименую в delete joint. Все, теперь мы можем воспользоваться нодой rig matchpos. Подключу во второй вход source скелет. Заметно, что мы выравниваем размеры по баунду нашей анимации. Это можно изменить тут. В любом случае, в дальнейшем, если есть такая необходимость, мы можем воспользоваться атрибутом SceneTransform. Опять же, в зависимости, куда мы его записываем. В данном случае в source, значит, со второго входа. Нам нужна будет нода Transform by Attribute, и там инвертнуть эти трансформации. Анимация, пожалуй, мне сейчас будет мешать. Я уберу ее. Я могу тут редактировать наши скелеты. Я даже могу в любой момент найти эти трансформации, развернув Tweak Pose. Это очень удобно. Я могу контролировать нужный мне канал или убрать одним кликом все трансформации с конкретного джойнта. Также с таргет скелетом. Я могу игнорировать конкретные точки, если мне это необходимо. Давайте для примера уберем с таргета. Также важно сказать, что все, что мы тут делаем, мы пишем в ResTransform. И если мы хотим изменить трансформации в качестве начальной позиции, выберем matchpos. Если нет, то pass. Я оставлю пока без изменений. Для нашей ситуации этого вполне достаточно. Сейчас я выберу Tweak Rotate и подгоню наши скелеты. Найду им общую позу. Нам не обязательно это делать идеально, но чем ближе, тем меньше итераций нашему экосолверу потребуется. Этого уже нам достаточно, чтобы приступить к маппингу точек. Я немного отодвину для удобства. И начну искать соответствующие точки. Через Shift я могу отзеркалить. Хорошо, этого, я думаю, достаточно сейчас. Сразу откроем Full Body Key. Тут и происходит вся магия, но мы ничего не видим, потому что мы отключили анимацию. Если ее включим, ничего тоже хорошего мы не получим. Дело в том, что у нас начальные позиции точек очень далеко друг от друга, и Full Body Key достаточно сложно это просчитать. Как бы не увеличили мы итерации. Но чтобы это сработало, нам нужно заранее записать рестовую позицию. Давайте, в общем, это сделаем. У нас есть нода StagePost для этого. Так, и помещаем это во второй вход. А анимированные в первый. И мы запишем на анимированный рестовые позиции. Теперь это работает замечательно. Ну, почти у нас есть какие-то странные сдвиги. Их мы сейчас решим. Джойнты достаточно близко сейчас друг к другу. Нам хватит и 10 итераций. И вот эти сдвиги, из-за того, что FullBDK достаточно умная нода, она будет стараться, но она не всегда может. И наша задача ей просто помочь. Мы перемапим эти точки. И мы видим, что уже все хорошо работает. В целом мы можем прям и все точки перемапить. Тогда вообще будет замечательно. Хорошо. Для начала давайте посмотрим уже со скином. Но если мы напрямую подключим, мы ничего хорошего не получим. Потому что мы удаляли кости. Поэтому спасением здесь будет нода Skeleton Blend. Подключим ее. Так, и выберем World Space. Вроде бы работает. Так, наверное, стоит и тут подключить. Да. Также у нас очень сильно сдвинуты плечи. Конечно же, мы можем просто перемапить, но я покажу немножко другой способ, поскольку не факт, что вы будете использовать антропоморфных существ. Для этого нужно сначала понимать, в чем на самом деле проблема. Включим отображение осей и заметим, что у нас они смотрят в разные совершенно стороны. И в этом мне поможет нода IK-Configure. Тут я смогу назначить веса для вращений в IK-контроллере. Я выберу конкретные точки, которые мне необходимы, и укажу значение в 0. Тогда FullBDK будет игнорировать наши joint. А теперь я смогу выбрать совершенно любую анимацию. И по сути наш плагин по ретаргету анимации с Mixama готов. Это будет работать совершенно с любой анимацией, потому что с Mixama именно точки не меняются. И теперь я перемаплю все точки, чтобы посмотреть, с какими проблемами мы еще столкнемся. Теперь у меня появилась проблема с большим пальцем. Я решу это в Rig Match Pose. Постараюсь подогнать максимально под референс. И также подтяну фаланги к друг другу. Сейчас немножко лучше. Также я хочу иметь контроль над самой анимацией. Но ключевых кадров у меня нет, и я могу только докрутить эту анимацию. Пользуюсь Rig Pose, например. И докручивать тут в качестве IFK контроллера. Но мне приятнее работать с инверс кинематикой, поэтому я попробую собрать что-то простое. Думаю, лишним не будет. Я выберу ноду Delete Joint. И тут укажу суставы предплечий. И установлю Delete Non-Selected. И переименую в Twist. Скопирую, назову Goal. И на этот раз возьму джойнты кистей рук. Также переименую сами джойнты. левый и правый, и выберу класс point. Мне понадобится rig-vob, подключу во второй вход twist, в третий goal и перетяну с viewport их трансформации. Также обозначу цветом для себя, чтобы не путаться. Также кисть, плечо и предплечье. Теперь мне нужно как-то возвращать трансформации. Я выберу set point transform и буду передавать по номеру точки. Все, теперь у меня все есть, чтобы достать to-bone key. И подключить плечо в root, предплечье в mid и соответственно кисть в tip. Ну и верну эти трансформации назад на точки. Также подключу наш twist и goal контроллеры. Теперь отодвину немножко twist и добавлю rig pose для контроля. Круто, это работает. И twist тоже. Но мы отодвинули по мировым координатам, и поэтому выглядеть это будет довольно странно. И на анимации это довольно заметно. Чтобы это поправить, я предлагаю воспользоваться снова rig-vop'ом и немножко сдвинуть нодой offset transform. Также выключу анимацию, потому что она мне мешает. И выберу правильную ось. Теперь могу докручивать анимацию на ходу в ВК-режиме. Но я также хочу для удобства добавить контроллеры. Я выберу, к примеру, бокс и уберу галочку с Pack Control. Также добавлю цвет и через поливар добавлю толщины. Правда, в этом будет больше смысла, если создавать ассет и в его состоянии указывать KineFX rig pose. Тогда выделять контроллер будет просто удобнее. Ну и лучше указать имя, я запишу на примитивы. Также для goal или target контроллера поменяю на сферу и объединю их. И теперь в ноде Attach Control по имени скопирую контроллер. Выберу темплейт через Ctrl, второй через Shift Ctrl. Также немного уменьшу. И чтобы увидеть цвет через темплейт, я добавлю его на точки. Но я не рекомендую добавлять контроллеры в ветку с анимацией. Можно заметить по иконке с часами, что в каждом кадре мы будем удалять джойнты и назначать их на контроллеры. Это может быть не очень эффективно, и можем посмотреть по частоте кадров. Но тут только один рабочий to-bone key, и просадка я вижу только по одному кадру. Я сделал это просто в качестве примера, и полноценный риг тут лучше не делать. Используйте для корректировки анимации rig pose. Вообще идеально будет, если редактировать анимацию еще до Full Body Decay и там добавлять эти контроллеры. Правда, следить за этим будет сложно. Также видно, что не очень естественно сейчас выглядит вращение предплечья. Вот. Как будто у меня выломана рука. Для этого мне нужно немного докрутить твист или сплит кости, который у меня есть на основном риге. И чтобы это сделать, мне нужно найти вращение для кисти руки. Давайте посмотрим в Geometry Spreadsheet и увидим, что у нас есть уже эта матрица на точках. Это атрибут Transform. Я предлагаю воспользоваться VOP атрибутом в режиме точек. Добавлю bind и по имени выберу Transform. В типе укажу Matrix 3. Возьму Matrix to Vector и выберу вторую компоненту, чтобы экспортировать через bind export. Назову, к примеру, Axis. И благодаря нижним подчеркиваниям я могу его легко найти в начале. Добавлю до дебага rigpos и для удобства отключу анимацию. Теперь я могу увидеть вращение. Я закреплю спредшит на атрибут WOP, а также по номерам точек найду именно кисть. И теперь, вращая по оси Z, могу видеть, как меняются значения. В данном случае третий компонент при 180 градусах становится отрицательным. Теперь я могу воспользоваться этими значениями, поскольку они находятся на числовой прямой. Добавлю уже rigwop, достану одну из сплит костей и, воспользуясь нодой rotate, спромоучу параметр angle. Буду вращать по оси Z. Именно по этой оси. Чтобы это сделать, я в axis укажу в третьи компоненты, то есть в Z1. Экспортирую сейчас трансформации обратно на точку. Повторю это также для остальных сплит костей. Теперь я вижу, что я допустил ошибку. Необходимо использовать локальные трансформации. Теперь переименую в axis для удобства в обращении. И чтобы достать мне значение этого атрибута, мне нужно воспользоваться функцией point. Тут синтаксис простой, мне необходимо сейчас указать путь к ноде, с которой мы будем брать этот атрибут, и номер точки. Также название самого атрибута, это axis. Это третья компонента, но поскольку нумерация идет от 0, значит пишем 2. Так, теперь мне необходимо отмасштабировать эти значения. Я воспользуюсь функцией fit. Впишу минимальное значение, это минус 23 сотых. Максимальное 23 сотых. И также сейчас впишу минимальное значение, от которого буду масштабировать, и до максимального 0,6. Скопирую на остальные. Сейчас я займусь подбором параметров. Я не стану сильно на этом акцентировать внимание и ускорю видео, потому что это более индивидуальный и творческий процесс. Теперь это выглядит немного более анатомично. Также, если на вашем риге есть Post Space Deformer, он тут работать не будет. Я предлагаю попробовать сделать что-то подобное с помощью blend-shape'ов. Нужно снова перефитить какие-то значения. Это можно сделать, как и все в Houdini, множеством способов. К примеру, высчитать угол между плечевой и локтевой костью, либо расстояние между плечевым джойнтом и костью руки. Пожалуй, последний самый оптимальный вариант, но в данном случае я снова воспользуюсь атрибутом axis. Теперь я воспользуюсь выходом геометрии, добавлю ноду blend-shape и также два нуля, один назову L-arm-rest и второй L-arm-move, и подам на вход в blend-shape. И теперь, нажав кнопку Update Channel Names, я подгружу эти имена. Важно выбрать также группу, на которую я буду влиять, потому что мы будем использовать целую цепочку из blend-shape'ов. И с помощью ноды Sculpt я постараюсь скомпенсировать деформации. А теперь я повторю тот же самый expression, только уже в blend-shape. Но теперь я буду использовать значение с локтевого джойнта, отмасштабирую от 0 до единицы. Теперь это выглядит намного естественнее. И сейчас я постараюсь повторить то же самое для правого локтя и для коленей. Все, теперь у меня есть некая импровизация на PSD, но теперь меня не устраивают веса, и я хочу немного подкорректировать в Paint Layer Capture. А теперь такой результат мне гораздо больше нравится. намного лучше, чем то, что было в начале. Теперь, допустим, я хочу поменять геометрию Софии на Андрея. Давайте покажу, как это сделать. В принципе, это несложно. Я сейчас подгружу геометрию Андрея и Object Merge добавлю в SOP. Теперь, чтобы мне было проще, я возьму веса из Софии, воспользуюсь я атрибут трансфером, уберу тут примитивы и возьму атрибут Bone Capture с точек. Ну а теперь я подключу просто в Bone Deformer вместо Софии. Ну, вроде бы работает, но у нас есть проблема с весами. И над ними сейчас придется поработать. Возьму сплит и разделю Андрея от одежды. Я также ускорю это видео, поскольку информативности оно особо не представляет. Снова скопирую веса, но теперь с тела на одежду. Но полностью избавиться от пересечений у меня конкретно с Андреем не выйдет, поскольку плотность сетки на теле и на одежде очень сильно отличаются. И когда разрешение сетки на одежде ниже, чем у тела, пересечения неизбежны, мы можем просто добавить субдивайдов на одежду, либо воспользоваться волюмами, но поскольку я делаю под real-time, мне эффективнее обрезать тело в тех местах, где мы не видим, и немного сглажу веса уже на самой одежде. Все, теперь если мы подключим Андрея, он будет тоже анимирован. А также я на руки добавил ему blend shape. Также скопировал скелет и немного подкорректировал его эдитом, поскольку анатомически Андрей и София отличаются. И теперь, если мы подключим новый скелет, все будет выглядеть намного лучше, особенно в плечах. Давайте подключим. Вот, видите? А также я подкорректировал немножко анимацию, поскольку в этой анимации плечи будто бы выворачивались внутрь себя. Если рикпоз выключить, это особенно будет заметно. Вот с включенным и вот с выключенным. И теперь София и Андрей могут спокойно работать с любой анимацией, которую мы скачаем с миксама. А также рекомендуется ставить перед Bone Deformer и анимацией ноду Normal и поставить на точке. Так эффективнее будет отрабатывать Bone Deformer. И, наверное, пожалуй, самое приятное, что мы можем экспортировать эту анимацию. Выберем ноду FBX Character Output и в третий вход подадим анимацию, во второй Capture и в первый геометрию. К сожалению, импровизацию с PSD придется игнорировать, поскольку ее можно экспортировать только в качестве секвенции. Тут укажем имя файла и нажмем на Save to Disk. Это был мой первый опыт записывания видеоурока. Я надеюсь, что вас не запутал и был вам полезен. В резюмировании, конечно, хочется сказать, что это лучшее решение для ретаргета, что я знаю, учитывая, что мы находимся в Houdini и можем это делать процедурно. Зная, насколько талантливое сообщество Houdini, хочется поскорее увидеть работы и способы применения инструментов KineFX. Ведь даже из того, что уже видно, можно создавать не просто риг, но и совершенно новые процедурные анимации без ключевых кадров. Возможно, полностью процедурных персонажей и наверняка огромное количество неожиданных применений. В общем, браво SideFX. Также хочу высказать благодарность Andriy и Фиане Вонг за их работу и поддержку. Вам спасибо за просмотр. Еще увидимся.
All right, next up we've got Adam Swaab. Hey, Adam.
Hey, how's it going?
Good. Welcome to the Hive.
Thank you. Thanks for having me. My first Hive presentation.
Yeah. So what's give us a little background on yourself.
All right. So I've been working commercially and professionally for a while, around 20 years or so. Been using Houdini for maybe 10, 12 years of that. And I've been everything from an animator to a designer to a creative director, but mostly I'm just an artist making stuff and trying to make things look as pretty as I can make them.
Cool. Well, what are you going to be talking about today?
Yeah, so I was fortunate enough to get in on the beta for 18.5 and also prepare some demo material for 18.5 around the chain SOP. And what I did is go a little further in depth with some of the setup for that, because one thing that's great with the chain SOP is that you can make the chains and you can link everything together, but what do you do after that? How do you get that into a simulation environment? How do you get everything to fuse together, and what are your options there? So I wanted to take a little bit of a more engaging route here and actually go through a whole setup and show what it takes to be really efficient and make it all work really well.
Right on. Well, let's get started.
Awesome. Thank you.
Hi, my name is Adam Swaab. Welcome to my Houdini Hive presentation. I'm going to be showing you how to use the new chain SOP in Houdini 18.5 to make something like this. I'm going to go over how to make chain parts, how to link them together using that chain SOP, and a smart way to get this working in an RBD simulation like this so that everything is just looking great and simulates really efficiently. So come along with me for the presentation. This is going to be a lot of fun. I'm going to jump right in and do a quick explanation of what this chain SOP is and what it's all about. So I'm just going to start with an empty file, make it pretty clean, and put down a chain SOP here. So going into my front view, I'll just give us a little curve to work with. So we'll do the draw curve SOP. And just give us some sort of little curve like that. Plug that right in. And we need to put some geometry in here to repeat. So why don't we go ahead and start with a torus. I'll change back to my perspective view here and just plug the torus right in. Okay, so the first thing that we see is that we have the torus repeated along this curve. Now the size of this torus is going to be related to the size of the incoming geo. So as our incoming geo grows or shrinks, you can see that the number of tori that we have along this curve changes. One thing you can see right away is that it is deforming as it moves along that curve. So for a lot of stuff, you might not want that. You might decide that you would rather have rigid objects here. So there is something in the chain SOP that you can enable for rigidity. Turn that on, and those become rigid objects. And then there is a mask that you can use where you can have an attribute that controls what's rigid and what's not. But I don't like to use this. I found that this is actually not so helpful for me. The main thing is that it's not efficient. It's fine if you need lots of deforming pieces, but if you do need rigid pieces, it's probably a lot better to just pack your objects here. Anything that needs to be rigid to just, oops, not pack points, excuse me, to just go and pack the object here. And so now you can see it becomes rigid. And the other thing is it's much more efficient because right now we're only really deforming. We're moving 7 points along here. And if we do it this way, then we have 2,000 points. So this is a lot more efficient just in terms of moving stuff there. So again, make sure my curve is actually visible so we can see what we're doing here. So the general setup with how this works is that you want all your different components coming into a merge. And then you're going to let the chain SOP sort everything out. So if we had something like this, and I'm just going to copy this setup here and put down a box. Wire that box right into here. What you'll see is that it's going to space these all out correctly for us. And the way that it chooses what to place and where is it's actually in the chain pattern. It's finding pieces by connectivity right now. And I'm going to show you why you might want to change this actually to piece attribute and be a little more organized about how you do stuff. But for right now, it's connectivity as a default. Now, the cool thing about the chain SOP and what makes it really interesting is that it is automatically adapting to the size of the pieces that are coming in. And that makes it really amazing because you can just act like a designer, start changing stuff around, and it already works the way it's supposed to work. And I think that's really, really great. So let's take a look at why you might want to do the name attributes. So I'm going to make some little links to go along with this torus here. And I'll do it really quickly, as quick as I can, that is. I'm just going to make another little torus. And merge this down here. Let's just go ahead and shrink it nice and small. So that'll be a link section. Then I'll mirror that so that we get one on each side. And let's just take this pack and put it up here. So we're basically packing this, and we will do a separate pack over here. So now what's going to happen is it's going to treat those other pieces like they're just separate pieces, right? And if I even turn this pack off, you'll see it's going to change and it's going to think it's even different. So what you want to do is, in that situation, basically put a name attribute down here, and I can call this piece 0. Call this one here piece 1. And then when I go into my find pieces, I would like to use a piece attribute. Make sure I grab the name attribute. Now I have my pieces how they are supposed to be. So I will keep this setup how it is, except I'm going to move this pack right down here. The next thing I'm going to do is basically take what I've done here, and we'll just go ahead and do the same with our box. So I'm just going to link these up. Just taking a quick look at my box, we'll just move that in like that. So we can see that we're not aligned correctly, number one. So we can go into our alignment, and we can change our direction to the correct direction. Now, obviously, the pieces aren't linked together. The way that we can solve this here when we're not using a deform mode is actually to change this to deform between pivots. That's going to move everything closer together. And I can even go in and do a piece rotation of 90. Now I can take my piece spacing and start bringing them closer and closer together. Now for something like this, you can see that our curve is basically curved more than what our pieces can handle. So we get some issues with alignment here, in which case you wouldn't want a curve that's this curvy. But it should work with most curves as long as you're kind of being true to what your piece of geometry can do. So that's pretty cool. I'm going to replace this with something different here. I'm just going to go into my front viewport here, and I will actually use a curve SOP instead. Oops, not curve SOP, but curve SOP. I'm just going to draw a quick polygon curve. Actually, I'm going to make it a NURBS curve first and then convert it. So I'm going to be a little more judicious about how I'm doing this. And convert that. And then swap that out. So the reason I'm doing this is to show you that for the most part, you can get away with just using something like a Vellum sim and simulating your geometry. But you will find that depending on what your sim is doing, you might see some things behaving a little strange. Like you can see that as your curve length changes, you get less pieces or more pieces. It's behaving a little unpredictably. So one thing you can do is you can change your mode, excuse me, not mode, your chain pattern. Instead of fit pieces long curve, you can say a specific number, in which case I can say that I just want 15. And then as I'm editing, let's just grab that piece here. You can see it behaves a little better. So what I had done in my piece originally is I had done something like this where I had done a full Vellum sim, and I just basically applied this chain SOP onto everything. But I found that it was producing some strange errors in there, and maybe that's adjusted in newer versions of the SOP. But I was getting things where there were like squashing and stretching of pieces, or it just wasn't really aligning the way I wanted it to and wasn't quite believable in the way that I wanted it to be. And you can see that in here. You know, some pieces do align quite well. I'm going to try to even adjust the spacing a little bit. Some align pretty well, some don't. You may be able to get away with this and it might work just fine for you. Or you might find that it's really not working that well for you at all. So that's why I ended up doing this rigid body version of this thing. And I'm going to go through that whole setup in just a bit. But let's cover just a little bit more about how this SOP works. So let's go back to our perspective view here. And I wanted to talk a bit about patterns. So one amazing thing in here, I'll change this back to fit along the curve, is that we can have patterns in here. So by default, it's set to cycle, and I can just change my pieces like so. We can also change this to an explicit pattern. Now, because we have names on our pieces, we can actually choose them by name. So I can say piece 0, piece 0, piece 0, and then piece 1. So that will give me 3 of the tori, and then a cube, and 3 of the tori, and a cube. And of course, you can offset that as you need. You can just do random, in which case you have random seeds you can play with. You can do a weighted random, and we have to specify number of pieces. And of course, these initial names are wrong, so I need to change those to the right names. So this lets us have a slider for probability. Do we want less of piece 0, more of piece 1, or do we want more of piece 0 and less of piece 1? So this all worked pretty well. The other thing that's really nice in here that the developers thought of is the ability to give you specified start and end cap pieces. And so the way that that works is really similar to how we're doing this here. So I'll just make it really simple. We'll just put a little sphere here. We don't need the connectors. So I'll put a sphere, and we'll say it should be about that size. I'm going to pack it and name it. So we'll go ahead and name that start. And maybe we'll just color that red. And I'll just duplicate that, and we'll color this one green and name that end. So merge these in. And right away, they become part of our pattern, which we probably don't want. But we can specify that there is a start piece we want called start. And now the end piece gets excluded from the pattern, we've got an end piece here called end, and that's there. Now there might be one small bug coming in here, as we do notice that our torus is not part of this anymore when we go into cycle for some reason. But if we have an explicit pattern, we can basically just do our pattern. I could say my pattern is piece 0, piece 1, piece 2, piece 3, and just sort that out correctly here and make it something that works the way it should. I'm not really sure why it's broken here in the cycle. It's supposed to be working, but for some reason there's something here. So it might just be a bug in this version of the SOP. But you can see that that works really, really well. And again, as our curve continues to adapt, I'll go into front view here. You should see that that is respected. So it's really nice. And what it means is when we start doing something like our draw curve, we'll go back right into here, is we can make a tool that basically designs a chain for us and then just paint it however we want or plug anything we want into it. So I can just clear that out and just sit here and start drawing my own chain that follows all those rules. So it's really, really quite nice. Okay, so taking a look at the next thing, we can add additional deformations in here, such as enabling rotation. We have a little ramp here, so we can basically rotate all through our piece. I'm just going to change this out so we have less chain to work with. So there we go. We can rotate through the whole chain. And we can also do scaling along the curve too. So we could do a little ramp or something in here. To me, this is a little strange because I would want it to uniformly scale. So there might be some issue here that will get addressed. I'm not exactly sure why it's not a uniform scale, but hopefully that's something that will be addressed soon. Turn that off. And now the other thing that I wanted to talk about is that there is an option in here to turn off your deformation. So what this is useful for is if you kind of have a template geometry such as this, you want to lay out a curve and take a look at how it looks along that curve, but then actually get a fully stretched out version of your chain and then rig it later. This works really, really well. And this can be really useful if you want to do some quick methods of simulating. So what I ended up doing for a different tutorial for SideFX was to lay out my chains like this and then run them through a path deform later. So I would do this and then I would just path deform after the fact. So I would take my chain in, and basically path deform it. And I went through that whole tutorial. It has the same things that we see here. The path deform was a really quick method of basically taking one chain, copying it a bunch of times instead of doing the same operation several thousand times. It was quite a bit faster for what I was doing, but you can see that if your curves are extreme, it's going to fail here. And you get a much less robust result this way than you would with just doing a chain deformation. So that's why I would choose one over the other here. I'll take that path deform out. But it's quite a nice option to be able to lay your stuff out like this and just be able to rig something this way. The other thing that is good to look at here is that you can control how things work with your curve alignment. So I probably need to go back here and change this back to enable deformation. you can have input points or input attributes on your curve that control how things are aligned here. So if I were to go and change this to curve normal, you're going to see that that probably looks a little bit better. We did flop a couple things here. I think I've got rotation on with the deformation, so let's probably turn that off. Oh no, I don't. But you can see we are getting stuff that does look right in terms of how it's working here. But you could also go in and do something like attribute wrangle. I'm just going to do a randomize. Just make something totally wrong. Like setting an up vector here and basically just having a random up vector. So you can see basically what that does is it puts the pieces in random orientations. So right here you can see a little bit of that problem I was describing before, where it looks like pieces are getting squashed a little bit. So that's kind of the bug. And I wonder if it's just because they're not normalized. Nope, they are. So I'm not quite sure what's going on, but this is the issue that I was having when I was just trying to use the chain SOP going into a Vellum simulation, as I was getting pieces that would get squashed and stretched and weren't quite right. So it's probably a bug to let SideFX know, especially if it's reproducible like this. And you can also go back into your alignment here and turn off your point attributes and let the chain SOP figure it out for you, which is fine. But if you're animating, potentially you could get flips. I'm not really sure what it's using to determine stuff for you, but it might not be the way that you want it to be. So let me take a quick look around here and see if there's anything else left to talk about. We're not going to deal with the attributes and stuff. That's not such an important part of this. I think the main things here have been covered. And this is kind of like the general workflow that I would do would be to set up a chain along the curve that you need. And then I'm going to show you the next part, which is to actually set up constraints for your pieces, bring that into a rigid body simulation, and then start simulating and making something that looks amazing. So this is the scene file for that skull chain simulation. And I've already pre-cached the simulation of the rigid bodies. And what we're seeing here are the chain parts that are copied back onto the rigid body data. And it's super high res. And you can see that I'm able to scrub pretty quickly in here. So it's quite efficient the way that this is set up. And I'm going to show you how exactly I was able to set it up like this. So let's go into our main pieces here. I'm going to turn off the chain and we'll take a look at the components. So the way I build this stuff is I do my parts separately and then I build a chain. And I have my bead 0 here. So let's take a look at what's happening. We have our first piece. And one thing that I keep in consideration, let me go into a right viewport here, is that the center of our linking points really should be sitting at 0. If we're aligning to the y-axis, which is what I'm doing in my chain, you want that z component, I'm looking at z that way, you want z and x really to be sitting right in the center so stuff lines up correctly. And you can see that I've built this that way. It's a pretty simple build. Basically, there's a model, a bunch of pieces brought in, material assignments, and then I'm just packing everything. And then for this one, I name everything at the very end, which is just bead 0. So I have 3 things going on. I've got my main model here, and then I have a collision geo. So the collision geo is me doing a very simple collision representation, which is going to feed into a bullet simulation. And I have a special group here, which is called collision, so that I know later on delete everything else besides the collision geometry and then feed that into the bullet simulation. And then there's also constraint geometry, which is not being used in here, but I'll show you that in the link section. And that all just goes out, it gets named, so I know that that's speed 0. And this gets fed into our chain SOP. So let's go ahead and look at link 0. This is the main thing that's holding everything together. Just like a real chain, this is the link. So It's a pretty simple model here. It's just a high-res geo going into one stream, and there's a collision geo going into a second stream, and then we have constraint geo, which I'll talk about in just a second. The collision geo I modeled not quite going all the way to the top and bottom, just because I didn't want overlapping pieces and I didn't want to make the simulation explode. I probably could have gone a little higher, a little lower on here, maybe puffed it out a little bit more, but this was working fine. This isn't a major part of the simulation. Mainly, I just needed an object in my sim that I could get position and rotation from to apply my high-res piece back. So that's kind of what that's doing. It's not really colliding with much in the simulation. So the main thing is this constraint geo here. And let me change my background so that we can really see it. So what I have are 3 points. There's a 0.0, a 0.1, and a 0.2. What I'm going to do when I set up my constraints is I'm going to draw a line. Actually, 2 different lines. I'm going to draw a line from 0.0 to 0.1, and I'm going to draw a line from 0.1 to 0.2. And these are going to represent the constraints that are holding the top piece to this link and the bottom piece to this link. I could have done 4 points in here. I could have, instead of having this point number 1 right here, I could have had that point here and then had point number 2 down here and then an extra point down here. But I just wanted something very, very simple for this. So this is how I ended up doing it. And basically what's going to happen is we're going to be drawing a line like this. Let's see if I can just kind of explain what's happening here. So we'll have a line like this. And basically what it's going to say is that 0.0 is going to get the name of the piece above it. And point number 1 here is going to get my current name. And we're going to draw a line between those. That's going to be our constraint. And then we're going to label this constraint type. So that's why we have this one little line set up right here. Now we'll do another line that's like that. And this is going to say that this point here is going to constrain to this object. And then point number 0 is going to constrain to the piece below it. So this sits in our sim just like so. And I have groups here for a link top, a link mid, which is right here, and a link bottom. This will be clear when I go into the next section about laying out the chain and setting up the constraints for why I have grouped and named these. Everything, again, gets packed, and I'm packing it for consistency so that the same data stream exists in all of the chains. And then I'm giving this a group name as name pivot. Again, you want to make sure that you're naming this stuff so that you can filter it out later. Everything gets merged in here and then just gets fed back out. And of course, it all gets named as part of link 0. And then the final end piece looks like this. It's a closed mouth skull. He's at the end. He doesn't need a little link coming out of his chin. So he's just got a link on the top, and it's basically the same thing. It's packed. We have a collision geo here. Quite simple. And, I didn't care about that, so I didn't put that in. I didn't really feel like we were going to see collisions there. I'm trying to be very efficient with how I'm laying this out. And then we have our constraint geo. And so for this constraint geo, I basically just have 2 points here. 0.0 and point number 1. What I found is that point number 1, whatever the bottom is kind of going to act like the pivot point. So I just kind of placed it where I felt was most appropriate while watching the sim. Kind of seemed like down there would be the best thing because it's going to connect to another link. That seemed like where it should be. I'll show you why I'm doing this when we get to the next little section here. Anyway, that all gets to an end name, and that gets fed into our chain SOP. So those are the pieces. Let's go look at how everything is now put together. We'll go ahead and dive into this chain SOP here. Turn off our point display. So this is kind of a big network. It's a little complicated, but I'm going to break it down so you can see what's happening. I have a little animated sphere here which it's going to be tough to tell what's happening because it's packed. But if I turn on my wireframe here, I basically just made like a weird little quad sphere. And this could be adjusted so that it's a little cleaner looking, but we never actually see this, so I didn't care too much about it. But I pack that first. That gets named sphere. And then I apply some animation here, which we're not really going to be able to tell unless we look at something like a UV quick shade. And that might need to be applied further up the chain before we pack it. Well, let's just skip the packing for a second so we can actually see what the animation is doing. Right? Pretty simple. It's just some expressions in here. Basically, that. Same thing. So eventually it will loop. I think it loops around 15 seconds or 10 seconds. Can't quite remember where that ends up looping. And that just goes into an RBD configure, which is just telling the rigid body solver that it is not active and it is animated. So it's going to pick up all that animation that I have on the packed object. And that's really it. So working from that, I just unpack it, basically scatter a bunch of points here, and build little connecting things. And these things aren't actually part of the simulation. I exclude these from collisions and exclude them from everything else because they don't really matter. They're not that important. And we actually never even really see these in the render, but they're there, and the chains really are connected to those pieces. So going up here, it's pretty simple. It's just make a chain. So it's what we were looking at in that first lesson about how to put the chains together. So we're just bringing in our pieces, which are pretty large, shrinking them down to an appropriate size, and then making a chain out of them. You can see that the chain has everything included in it. It's got our rigid body objects, it's got our high-res geo, and it has our constraint points. And then from there, I start to break things out. So we go one direction, which essentially is just deleting our collisions, deleting the pivot points, and then making our chain here. I've got some sorts and assembles and a few other things. I'll go into that in just a second. But basically, that's like, just give us our high-res chain here. Now the second one, I'm going to get into constraints last, but let me do this other one here, which is up here, which is just our collision geo. And so here, all we say is just delete everything that's not a collision object. And now we get a chain that looks just like this. I'm sorting everything based on Z. The reason that I'm sorting it is if you do look at the point numbers, let's go into wireframe mode here. You can see that they do come in out of order because of how the chain stop is laying stuff out. So just to be consistent, I chose to lay it out 0, 1, 2, in case that helps me match stuff back up later. And that's all that sort is really doing. So from here, we're assembling stuff, and I'm assembling it with a name attribute. I'm letting the chain create a name attribute for me, or letting the assemble stop create a chain attribute for me without repacking. And the reason I'm doing this is for simulation. If I go into my spreadsheet here, and I'm looking at the sort, so before the assemble, and we look at the name, they all still have the same name from when we brought them in. And that might be fine for laying out a chain, but when we get into RBD sims, Bullet's going to want each object to have its own unique name. So the quickest way for me to do that is to just use the assemble stop. Go into my spreadsheet. Now you can see we have individual names here. And then from there, what I've done is I have said that I want to pin my first point, my first object here to the animation that's coming in. So I've said that first piece, and I've specified that as group 0. I've said that first piece is animated. With default value of 0. So all the other pieces get an animated attribute that is 0, but this piece is 1. And then I go back up and I think active as well. So I say that this piece is not an active part of the simulation, which means it's just going to read the animation. It's not going to be bonked around by other objects. It's just going to be kind of a moving rigid body in the simulation. But everything else has a default value of 1, meaning those things are all going to move around the sim. So just creating some things there and then naming it, attribute promoting it so that everything is matched up correctly when we get into the simulation. So the other side of this is the constraint side, and this is where it gets pretty interesting. So what we do here is we keep only the constraint geo, and I'm just sorting those again, just so everything is matching up nicely. So we can see how this works. We've got our stuff at the beginning. These are all the links. Remember, we had 3 points in our links. And then we have those points right at the end here. And I'm basically just unpacking everything. So what we saw before when we saw those other points, we saw the center points, which represent the center of the packed geometry. But we unpack these, and now we just have only the construction points there, only the geo points. So these represent the links between everything. And then I just use a connect adjacent pieces here. You can see I'm looking for adjacent points and kind of fine-tuning this search radius to draw these connection lines between everything. The only problem is that they don't know how to get the name of the object they're connected to. So what we do here is, let me show you where that's coming in. So we're looking at this attribute promote name, looking at this assemble that's coming in. And all I do is I am transferring, using attribute transfer, I'm going to transfer the name of this object after it's already been renamed by the assemble SOP. I'm just going to transfer that name to the points here. So I need to make sure that these points are kind of sitting close to wherever that pivot point, wherever that center of the packed object is going to be. And that's part of the reason why I had those groups. So I just take my link tops and I just extend them into the center of those. And I take my link bottoms and I extend them that way. And then I have the same thing happening for my end top. I had a group there for end top, which is going to extend that right into there. And my end bottom is just extending that right in. So now my constraints are all the right, not the right length, but they are going to work with an attribute transfer. And that's what I'm doing here, is attribute transferring the names. Now we will see that the names are doing what they are supposed to be doing. But the rest links are all wrong, and the links are all wrong. So I go and grab my original connect adjacent pieces, and all I'm doing is just copying that name back to the original ones. So now I have the right rest lengths, and by the way, the rest length is set here. So I have the right rest lengths, I have the right names, I can sort it if necessary, clean anything that doesn't need to be there, and that goes right into an RBD constraint property. And so here what I'm doing is setting my constraint name to hard, which is going to let it in position only. So position only is going to let it rotate as it needs to, but they're going to be position constrained to each other, and that's why they don't separate. I have a little setup down here which you can use or not. Right now what's happening is they can basically rotate 360 degrees around their pivot points. But if you wanted to change that, you could do something like this, where you just duplicate your constraints, and then they'll really only be able to go in this axis here. They'll have a little bit of wiggle room, but that's one way of doing it. There are much more elaborate setups that you can do with cone angles and stuff like that, but I wanted to keep it fairly simple for what I'm doing here. So what I do with those is I'm using the new SOP RBD stuff, which is fantastic. I just take my SimGeo, going right into my RBD pack, and then my constraints going in RBD pack. And you do have to make sure that your names are consistent. You're actually matching the right thing up with the right name. So definitely double check that. So that basically packs everything. it says, give me the objects and give me the constraints all together. Then that goes into a copy to points. So now I'm bringing in right here, those are my points from that geo, and these are animated. Remember, these are animated points, so when I move this around, this thing is all moving with it. I don't really need to pack this, but I did. You can pack it or unpack it, it doesn't really matter. It's a little faster to pack it, but then right afterward, you just have to unpack it again, so still works fine. And then this goes into an RBD unpack. So what an RBD unpack does is it spits out RBD objects and constraints from an RBD pack operation. However, there's something special here, which is that I can tell it, make sure everything gets a unique name per instance. So if you look now at, let me see if I can just right click down here. Not sure I can, I'll put a null down. And we'll take a look at that name. So if you look at the names coming in now, this might be point names. Let's hide everything except for name. You can see that our naming convention is now changed, where it's identifying each one of these with a unique name. If you turn that off, you'll see that you get names like before, and you get multiple pieces with the same name. Again, you can't have that happen in your rigid body simulations. You have to have unique names or else the solver does not like it. But that's one of the advantages to this whole RBD packing and unpacking setup that's here in Houdini, is that you can make one thing, set up all the constraints, get that part perfect, and then make multiple copies of it and just have it work in the sim. It's a really great way to package constraints with geo at the same time. So here, all I'm doing is just merging that sphere back in. You can see that it's right down in here. And then that just goes into our RBD solver. So remember that piece that was right in there, the connecting piece, that is set to animated. So even though all this stuff is moving, when it gets into sim, the only ones that it's going to see as animated are the pieces that I've tagged as animated. Everything else is going to be evaluated only once, meaning the geometry is going to be fed into the simulation on that first frame, and then from then on it's going to be part of the simulation. But everything that's animated is just going to be getting its data straight from SOPs. So that goes into a rigid body solver, and I didn't do much here other than change the forces here. So I've got a little bit of gravity that I've adjusted, some air resistance, my spin resistance. I have a ground plane, but I'm not really using it, and that's kind of about it. I think there was one other thing that I did do, which was in my solver settings, I upped my constraint iterations quite a bit. What I found was that the pieces were actually separating more than they should. And the way for me to get around that was to do a lot more constraint iterations, so stuff held together the way it's supposed to hold together. So you can see that the sim is not real time. There's a lot of pieces going on in here, but it's not bad. It's not horrible. It's not too slow. And it's a lot better than if I tried to feed the high res geometry in here. So let me pause that for a second, and we'll go over to the second part of the network here. So second part is taking our high res pieces, and what I've done is I've gone through the exact same process that I did with our low res pieces. This is literally just a copy and paste. All it's really about is just bringing it in so that everything is named the same. Everything is in the position that it needs to be, so that when I copy it back as it's supposed to be copied to our sim, that things end up in the right places with the right names. So this is what that looks like as a copy to points, and this goes into this sim post process. So all that's doing is bringing in our RBD object from that DOP network. You can see that. But I am bringing this in just as points to represent the objects. So you can see what this looks like. Basically like that. I'm looking at the pre-cached data here. So very efficient. You can write this out to disk very, very easily. And now this goes into this setup here where we're just RBD unpacking, enforcing unique names. Again, this is a mirror of what's happening in the low-res sim. And then that goes right into a transform pieces SOP. And so now we see that our high-res pieces are picking up all that low-res data and all the transformations in here. And it's all holding together because of the constraints and how it's all set up. And the rest here is just writing it out for rendering. I will note that I did have some issues rendering this out of Redshift. I had to do a little bit of a secondary process here, so I have a whole other thing just for Redshift exporting. I'm not sure why I was reading the pivot points wrong. And for anybody running into that, what I ended up doing is just writing out the 3 little pieces of geo separately, bringing in my data like this, writing these transform pieces out, the packed pieces, and then just reapplying all the packed animation to my individual pieces. And it rendered really fast. My render for this was probably about 40 seconds a frame on my machine. So it was very, very fast and efficient render. And that's basically the setup for this. So it's not too bad. What I would take out of this lesson is the ability to package and pre-package all of these little pieces together, including their constraints and their low-res geometry, and being able to feed that right into a DOP network is amazing. It means that you can keep playing as much as you want. So if I wanted to, for instance, make less items in here, what I could do is change my line here. By the way, I set this to explicit number of pieces. You could do fit along curve or whatever works for you, but I could do fit along curve. And I can change the length here to something short like that. And because the setup is already working for us, I can just go into my RBD solver. And you can see now we get this much shorter, little bit of chains. But all the constraints are going to work automatically for us. We don't need to update any of that stuff because we built a system that will do it all for us. And we can see it's a nice quick sim. And I can also just visualize my post sim process just by turning that off. So I can watch one thing and I can sim one thing and view the other. It works really well. And if we wanted to take a look also at this setup here, all we would have to do is just pop that right in like that. And just let me make sure it's current. I'm going to go and reset my simulation. And you can see everything is still holding together. We'll zoom in just a second and take a quick look at some of those pieces. This will have a lot less twisting in it than the other one did, just because of how the constraints are laid out. And you can play around with all different kinds of constraints and build pieces as you need in here. We can see as things are starting to collide together, it's all looking pretty good. The pivot points are doing what they need. There's a little bit of twisting there at the end. A couple other things worth looking at, and that might just be actually because of how I set the sim up. It is that link isn't right. So I would just quickly go back in. I can tell just by looking at that what we have going on here isn't right because of that. And that was part of the reason why I set this to explicit number, because that way I can make sure that my end piece was actually sitting the way that it needs to be. Because you can see if you go to one extra one, that's not going to work. So I did that so the end piece sits in. So just taking another quick look at that sim, I'm just going to reset it. And then we'll take a look at the high res transform. So we can see that's actually sitting correctly there. And the reason that didn't explode is because I don't have collision geometry. at the top of that thing. I didn't really care much about the links and how they collided. I felt like that was a really minor part of how the simulation dynamics work for something like this. I was mostly concerned with the big skull shapes. We can see now that's holding together much nicer and looking correct. So I want to thank you for watching this presentation. Getting to play with the beta of this piece of software and this tool has been incredibly fun. This is just really wild. I've certainly enjoyed it, and I think there's so many amazing, amazing things that people are going to make with this. It's just going to make everybody's life so much easier when they're doing this kind of work. Thank you very much.
Hey, next up we've got Luiz Kruel. Hey, Luiz.
Hey, how's it going, friend?
Good, good. So you've got an update for us.
Yeah. So this is being shown in the future, in a future that I'm no longer part of SideFX. So unfortunately, tomorrow is my last day. We're sneaking this in under the wire to make sure we got one good last presentation in there. It's been an incredible 4.5 years. I met a lot of people that are amazing. The crew at SideFX was some of the best I've worked with. So I'm incredibly grateful for the opportunity. And it's going to be a shame, but I'm sure I'll see you all around internets and in person when we can.
Well, we're going to miss you a ton, but can't wait to see what you get up to next.
Yeah, it should be fun. Looking forward to it.
So what are you going to be talking about today in your presentation? So
I'm going to be talking about KineFX. So KineFX is something that I've been involved in since the inception and the whole decision to switch from object level rigging to SOP-based rigging. So I'm going to be focusing particularly on how it relates to games and how similar it is to, say, a game state machine. I'm going to go through the whole, what is KineFX, what does it look like, some of the new integrations that we have for mocap suits and how to set those up, including how to send it to Unreal, and just kind of a big overview on how to use the new tools.
Right on. Well, let's jump in.
Hey everyone, this is Luiz. One last time, I'm going to talk to you about some KineFX for games. Again, based on the intro, this is my last presentation for SideFX, and I want to thank everybody for kind of hanging in there with me and kind of coming along this ride for the past 4.5 years. It's been a great one, and I really appreciate everything that everybody has done for me over the years with sharing information and just kind of helping me through stuff. And I really appreciate everything that the community has done. But now let's get into it. So let's talk about KineFX. And I'm incredibly excited to be finally talking about this publicly. We've been working hard on this for over 2 years, I think, is when we started planting seeds on what became KineFX. And it is a game changer for Houdini. And I'm very, very excited to be able to talk to you about this today. So without further ado, I'm going to shut off my video and we'll get to it. All right, so rigging in Houdini today. It's not what we're known for, so that's a nice way of putting it. And currently everything lives in the object space, which means it's not procedural at all. So it's one of the least procedural parts of Houdini, if not the most non-procedural part. So what we decided to do is actually move it away from the object level and into geometry level. So we're moving rigging from the object level, object context into SOPs, which is amazing because now if you want to say mirror a skeleton or add a chain or add a constraint, you can do it more through nodes and you don't have to really script anything with Python or there's not, it's much better. And I'll show you why. Rigging in Houdini now, people have shipped games with it. They've shipped the movies with it. But realistically, it was kind of time for a reboot. So I'm really happy that we managed to get everybody on board and pull the trigger on a really drastic change for one of the kind of core parts of Houdini. So an overview of KineFX. So it is based in SOPs, like I mentioned. The primary focus is for kind of data processing, so dense data processing. So you can think of mocap for this. And the thought here is that Houdini is great at data processing, be geometry, volumes, images, and animation should not be any different, and skeletal meshes should not be any different. So it is kind of our DNA to kind of chew through data, and I think mocap is where that lines up the most logically first step for us. It is very much inspired by my state machine, so this is a little bit specific for games, but if you know what a state machine is or have used one in the past, this should feel right at home, which is weird for a DCC to go down this path, but it lends itself very much for the way Houdini works with nodes, and you chain nodes together and you override poses and you add dynamic parts to it. It is very much lends itself to work like a state machine. And this is the first update, right? So this is a longer road here. We are going to get all the way to where an animator can sit in Houdini and work. But right now, that's not where we are. Right now, we're in the foundational kind of framework level where a tech animator should be able to sit and comfortably do everything that they need to do. For future releases, we'll get closer and closer to that artist-friendly workflow. But for the time being, we're still very much on a tech art, tech animator space. So let's see what this actually looks like in action. So this, I have a pretty classic scene. You can see there's only 1, 2, 3, 4, 5, 6, 7, 8 nodes. Very basic. We're loading in an animation through FBX. And then our first thing is we're going to do an offset on the leg. So you can see the animation is still flowing through, but I can just modify the rotations of that joint. And if you want to kind of hide or change the visualization so it looks a little bit more like your traditional bones, you can with the fins. And now we still have all of SOPs available to us. So here we're just isolating the feet. We have some handy terrain, and we're going to raycast those feet against that terrain. And it's kind of hard to see here, but it is actually kind of doing what you want it to do. And then we can feed those new feet positions into an IK solver. And that will give you kind of what you expect, which is the original motion with an offset intercepted plus IKs on the feet. And because this is Houdini and everything is live and everything is always cooking, this is very much non-destructive. So you can change the terrain, the feet will adapt for the terrain. And you can also add different offsets in different areas. Animation still works. Everything works as you would expect. And it's worth mentioning that the bones are just pieces of geometry. So the bones themselves are points, and then the connection or the hierarchy is displayed with curves. And then if we want, we can kind of drop this rig pose node wherever we want to add more offsets. So in here, if you want to, after it's been raycasted against the terrain, you want to add a little bit of an offset. And maybe you want to actually animate that offset. So you want to set a key here and over there. You can. So the currency that passes up between all of the nodes is just points, just like any other SOP. And any animated data or animated parameter lives on the nodes themselves. So here is where that animation curve is going to live. It's essentially baked down to the skeleton the moment it comes out of it. But if you need to go in, you still have those two keyframes exactly where you left them, even though you ran through an IK or you ran through more stuff. Wherever you have your sparse data, you maintain your sparse data, and then the dense data is just kind of implied as the next node that you're coming in is going to have dense data baked into it. So I mentioned that this is a curve and this is a regular piece of geometry. So I want to prove that a little bit further by showing you this is our humble curve SOP, which is due for some love. And here I'm using the rig pose because by default, the regular curve SOP or any SOP can't really deform a curve as if it was a skeleton. And like I mentioned before, we can also change the look of that curve to make it feel a little more bony. So it's when we started doing it, it was a little bit of a mind blowingness to be able to kind of just work with curves, and it felt good to have these little fins drawn, but it's entirely a preference that you can or disable or enable once you get used to things. And yeah, so it's just basically it's geometry, and the currency is you have a P attribute for your position and you have a 3x3 matrix for your transform. Transforms are stored in world space, but you can convert them to local space, do things to it, convert the matrix to Eulers, convert them back, move them to quaternions, whatever you want to do. Again, it's just data that Houdini can sling around without any problems. Then we get into an actual character. So this is us bringing in this character done by the great Christoph Tessi. And here you see that there's three kind of chains of data flowing. So the first one is skinned mesh. The middle one is a bind pose skeleton or a rest skeleton. And then the third one is the animated skeleton. So here you can see I am just adding some keys and I'm just going to move the arm up and down really basically in FK just to show again that you can animate a character and you can kind of visualize what the skeleton is doing with the bone deform. So that's what actually calculates the skinning. And then if you want to export this out to FBX, it's just a ROP as you would. So this will export out skinned skeletal meshes. And we can just save that out and you'll see I'll bring it into FBX review and it's doing what you expect and we can export that out. So even this, for people familiar with animation in Houdini, is magical because getting a skeleton to kind of round trip, add animation to it, export with the same hierarchy, were all pretty hard things to do before KineFX. And now it is pretty much what you kind of expect and hoped it would be. Hopefully you're happy and hopefully we hit the mark, but at least it's what I would expect from Houdini handling these things. So again, we have these three data flows that we can intercept any of them. And now I'm going to kind of show you how we can intercept or create new ones of each of them. So we'll start with the first one, which is the skin mesh. So one of the kind of top features, or one of the first features that even if you don't care about mocap, you don't care about animation, a lot of people will use is poly reduction on skin characters. So here we have a character from Paragon from Epic. And I did a little bit of already cleanup here. You can see I did a blast to remove all the LODs. I did a conversion from polysoup back to polygons. I don't think that's necessary anymore. And then some UVs. But I want to also apply an animation to it. So now what we're seeing is I can poly reduce a rigged character with animation playing through it completely non-destructively and see the updates. So I can basically play back the animation. I can detach the animation at any point. You don't have to kind of save it or dump it to disk and then reapply it. And you can kind of just be aggressive. You can see here there's a little bit of a stray vert. And at that point, you can either just kind of go in and smooth that out, or you can just say, okay, let me play back. Maybe that was a little bit too aggressive. That's where things started falling apart. Maybe that's as far as I can push my LODs. Again, just this is our bread and butter of Houdini. So we have the original, and we can kind of start decimating by halves in each of these. And then by the time we get to the last one, it is a complete new mesh. So LODs 1, 2, and 3 were done with just the poly reduce and nothing else. And then LOD 4 actually it's a voxelized mesh. So you can see all of the kind of machinery becomes one big bloop. And then the UVs and the skinning are just attribute transferred over. So there's no extra magic here. Poly reduce will interpolate the skinning properly. And if you want to do things with attribute transfer, you can as well. And we can see this is not baked at all. I can just swap out the animation, see a different animation and all of the LODs, see it. And you can also see that I'm playing 5 Foley characters with high quality lighting and everything at around the 20 FPS. If I go to wireframe, it goes up to 24. And yeah, so we're very, very mindful of performance and wanting to make sure that it's a smooth experience as much as we can. So now we'll get into building a skeleton. So this is your bread and butter joint creation tool. It's our skeleton node, and it has a lot of different awesome snapping capabilities. So the regular point snapping works, but we also have snapping based on the view camera. So it basically finds the center of the geometry automatically. You can tweak it. You can tweak it with child compensation. And you can kind of just go in and start placing all the bones that you want. You can add more bones. You can reparent them. all very interactive in the viewport. And yeah, so it becomes pretty easy to go in. If you want to change the orientations of a bone, you can just simply go in and grab the bone and rotate it. Or you can use predetermined kind of orient operations, and maybe you just need to fix the up factor a little bit if it didn't give you what you wanted. So here we'll just kind of continue building through. Again, pretty easy to go in, and even if it doesn't give you what you want exactly, you can just go in and quickly just kind of change some things around. And you can also, if you press P, that will give you a parameter for the state, which you can go in and actually zero out joints. So in this case, I wanted things to be exactly on 0. So I can just simply go in, hit P, and get the actual positions of each of the bones. So here I can just go in, play with it a little bit. I'm pretty happy with how that side works. So now I can mirror the skeleton. So it's something that I mentioned earlier, that if you're doing this in object space, now you're in Python land writing how to duplicate nodes. But because this is geometry, we can very easily just mirror it out. But you'll notice that my skeleton is not, or my model is not symmetrical. So I can drop another skeleton node that can operate and modify an existing skeleton as an input. So you can either pass the skeleton without any inputs, or you can pass it an input and the skeleton node would actually go in and modify it. So in this case, I'm modifying the duplicated skeleton, so basically the other half, and I can quickly just place everything where it needs to do. So you can see pretty quickly I put a bunch of joints down on this relatively complicated character with multiple limbs. Then we need to bind it. So this is one of the fun parts for Houdini. So of course, I'm going to show you the long way of doing it. You can basically build an HDA, which I have for my case. But you need to drop a bone capture lines, which basically add some, resamples the curves or the skeleton. Then we need to drop a tet embed, which generates a tetrahedral mesh from your original mesh, which is going to go into the biharmonic capture node. So here you can see we're just generating the tets, and this I didn't speed it up. So this is as fast as it goes. There's no shenanigans here. And again, if you have this as an HTA, it's just a single node. But it's 3 nodes: bone capture lines, tet embed or tet conform, and then biharmonic capture. And now I can basically feed this into a bone deform and do my usual rig pose trick, so we can start looking at the skinning. So you can see now we have, and I have to change the display flag. So I looked at the actual deformed one. I can see that it actually does a pretty good job with capturing. And this is going to move some joints in the background. Then I can kind of play around and find the joint I actually do want. And we'll get into custom controllers in a little bit, so to kind of mitigate some of this. But here I'm moving the arm, and you can see, yeah, it's good, but it's a little too soft. So I want to kind of separate some of that out a little bit. So let's get into painting weights and kind of actual skinning next. So to paint weights, the way I like doing it is basically I use my rig pose node and I actually set some keyframes. So I actually have a little nonsense range of motion fake animation on it. So ideally you can actually use the full mocap, which is what I do on characters. But on this character, I just manually move the arm up and down. I drop a capture layer paint SOP, which is the same mold that we had. And I just set a couple of things. So you can actually change the preference. So middle mouse becomes the region selector. So you can basically middle mouse around and select the different bones. And then you can just basically start painting as you would. You can see I can quickly paint areas that I don't want. I can switch from paint to reduce. All with just right-click menu in the viewport. Can change the visualization to be infrared just to make sure everything is actually there. And sometimes the black values are hard to see. Then you're basically doing bread and butter stuff. And the nice thing here again is that there's animation, and you don't really need to bake it out or write out the skinning to disk or anything. It's just you can just disconnect that rig pose or just delete the keys out of it. So here again, just start moving down the joint chain, and You can middle mouse to select the different joints. So here I'm going to actually be painting across 2 different joints. So I can draw one, middle mouse click, select the other one, start filling it out. You can really easily just see the volume. And then we can actually start smoothing, which is something that in other softwares it would be heresy because you would get weird skin data across everywhere. So it is worth also mentioning that we do have pruning and regular procedural ways of altering the skinning data. It's just an array attribute, so you can kind of do whatever you want. You can do attribute promote to detail to get the max value and then flood them back down, and it's really powerful to do things like robots and mechanical rigging. But for your traditional painting of weights is also really, really powerful and really, really fast. And then next we'll get into kind of the whole band playing together. So I actually made some mistakes when I rigged this. So I actually needed to add some more joints. When I started wanting to paint weights on the claw, I realized I just didn't have enough joints there. I have it forking, but I don't have it actually where I need it to be. I kind of have it at the end. So I just go in and I quickly add some more points on both sides of my skeleton. So I did one side, then I'm going to go in and just quickly add some more bones. Getting it so just the view is perfect. And you can see by just clicking on the other joint, it reparents it. And it just feels nice. It just feels like what you would expect if you were with one bone selected and the other one. Now it basically ran the tetrahedralization, the biharmonic capture, and the capture layer paint. So none of this work that I did before, even though it was a different skeleton, it didn't really go away because the capture layer applies itself back based on the name of that region. So it worked out pretty well. So you can see there, it's still clean. There's nothing weird about it. But now I want to kind of start skinning this claw that I set up. So I do my usual trick of doing my fake range of motion. But I'm noticing that it's not really rotating from where I need it to rotate. So I'm going to drop an additional skeleton sop because I don't want to keep redoing the skinning every single time. The skinning is okay and I'm going to be overriding it, but I do care about where it's going to be animated. So I can just change the bind pose kind of while I'm painting weights and animating. So this is pretty incredible workflow, and it feels amazing because you can. I usually struggle with finding the perfect place to place a joint, especially on hands. It's kind of tricky to make sure that the hand will be able to make a fist if you're rigging an open hand. So usually you have to just deform it and kind of see it. And a lot of the back and forth is a pain that you kind of have to apply the animation. It does break it down. Maybe you have layers. But here you can basically see what the joint placement is how it's gonna affect the animation. You can see, okay, that was probably a little too low. So let's move it up a little bit. Yeah, that feels a little bit better. So let's leave it probably a little bit closer to that. And as you're kind of finding where the pivots are for that animation, you can always kind of come back in and paint. So again, this is something that used to take me probably hours to kind of sit and go back and forth. And honestly, something that some riggers really like because there's a zenness to it where you just kind of sit and you're kind of combing grass and kind of arranging sand. But in a lot of cases, it is kind of, you just need to get the job done and move on. So this makes that task a lot easier. So again, you can come in and just smooth some stuff out without fear that you're going to be setting some influences somewhere in a corner. And you can kind of just go in and you get the idea. So again, incredibly powerful, super useful, and I can't wait for you guys to play with it. And you can see I have a little bit of a straight weight over there that I can kind of just go in really quickly, go to reduce, kill that, and be happy. So now you've seen how we can create skeletons. You see how we can modify the skinning, we can modify the geometry, and you can modify the animations. But let's see how I actually do rigging in the traditional rigging sense. So the constraints and the expressions are kind of handled by our VOP network. So it's basically a rig VOP, which is very similar to a point VOP, but it kind of has some some setup to calculate some stuff for you, so you don't have to worry about it. And then we also have a couple of SOPs, or one or a few, basically, related to the full body IK. So you have the actual full body IK solver, and then you got a couple of configured nodes to set up some actual constraints and weights of the solver. All right, so now let's take a look at how to actually set up this constraint setup. So in this example, I'm just going to start again with the simple curve. I'm going to add 3 points, and this is going to be a leg. And we're going to, first thing we need to do is add a rig doctor node, and this just initialize the names, attributes, and the transforms for me, so the IK solver can actually set everything up. I'm also going to do a NAD SOP with delete geometry but keep the points option, and these are going to be my control points. I'm going to feed both of those into a rig attribute VOP. And here we actually have a really cool feature where you can just click and drag from the viewport into the VOP area. And here I'm just going to take all of my points. So it's going to be 3 controllers and then 3 driving or things that are going to be driven. And then I'm going to feed those results into the output. So basically I have my 3 bones, my 3 controllers, and then the 3 outputs. And here you can see if I move my controllers around, I can basically solve that curve in an IK solver fashion. Again, no magic here, it's just regular geometry that you're moving around, but it is just, instead of an extrude, the operation that you're doing on the curve is a 2-bone IK setup. So again, just like you saw in the very beginning, you can make this procedural, you can have this go up and down based on a sine wave, you can have it collide against the terrain. It's up to you really how to skin it. And you can actually add offsets to it, you can do all sorts of fun stuff. You can turn this into an HDA as well. So if you just want all of that to kind of sit into a custom rig, that is also possible. But this is kind of the lowest level, how to do that setup. And then just to drive that point a little bit further, because people are like, no, really, can you do this with like an L system? Again, here's that same setup. So we're going to use the rig doctor to just initialize some stuff. Now we're going to use the blast this time because I don't want every single point as the control. I just want to say these are the things that I want to drive, and these are going to be the target. And we're going to use, instead of the rig attribute VOP, we're going to use the full body IK SOP, which is even a little bit easier to set up. So we can basically say, here's my controllers, and here's the thing that is going to be driven. Instead of mapping based on an attribute or based on a mapping index, we want to map it based on just a name. And you can see here, all I have to do next is spin the root of the full body IK. And I'm applying the full body IK solver to something that is not human at all. So this is just an L system tree. So it works with quadrupeds, it works with any kind of chain. This is pretty powerful. Again, if you need to animate some trees, or if you need to animate anything really, even like pieces of destruction or rebar being bent, the full body IK solver will work for it. And you can kind of build these little constraint setups pretty easily. But who wants to rig trees, right? So let's look at, again, that character, this time with some textures. And here, again, exactly same setup that we did for the tree. I'm going to select some of the targets that I want to be. So it's going to be the hands, the head, the pelvis, and the 2 feet. I'm going to blast those, basically everything else away. And then that's going to go into full body IK. And that's going to go into my bone deform. And then again, we just have that rig pose to add some offsets. And you can see now we have a basic rig, so you can start posing your characters. So here again, very, 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 very basic rig, but it's something that you can start playing with. And you can see the feet are a little bit sliding there. So I actually want to do a couple of things. So first, I want to parent my hands and head to my pelvis. So again, I can drop that same skeleton node that you saw it, and to do that same operation. So now when we move the pelvis, or when we animate the pelvis, the hands and the head will move with it. So that's kind of mini rig number 1. And then we can actually start playing with the full body IK a little bit to just give us some better results. So we can add some configuration to where we can say the feet have a little bit more priority than the rest. So we do want to kind of keep the feet a little bit stronger. And we also want to kill the dampening a little bit. So it's making the whole body a little bit too stiff. So it's kind of moving, progressing the weight of the feet all the way to my pelvis where I don't want. I actually want that knee to bend a little bit. So again, here, super basic. Even if you know anything about rigging, you can see with like 3 nodes, we have something that you can actually start posing a character and start. Actually, if you wanted to animate this, you could. Animators are going to want something different, but proves the point that it is pretty trivial to kind of start setting these things up. And we'll start ratcheting up the level of complexity, right? So in this case, we have the same character being the driver of the full body IK. So we just kind of made a little sibling rig that we generated on the fly. But what we want to do next is actually transfer motion from a different skeleton onto this. And it's the same setup. So I'll share that here. So here I have another animation clip, just a range of motion that I have I captured. And here what we're going to do is go through the whole process of retargeting live. So the first thing we're going to do is the rig match pose. Basically just make sure that both skeletons have the same pose. So basically if you have one in an A pose and the other one in a T pose, it puts them both in the same space and kind of calculates offsets based on that. So here we can kind of pull the scale a little bit down just to make sure that the hips are the same. Next thing we want to do is the map points. And this is you're basically in the viewport clicking and dragging to determine the relationship between the bones. So you say left bone now becomes left foot. Spine 1 becomes spine 2 becomes spine 3, so on and so forth. I'm going to let this play, but you can see how quick it is to do this. Once you do it, you can either export the mappings out. So usually you have a mocap to game mapping. Then you do that setup once and then you can reapply it. Or you can use our preset system to also reapply that. So that works just as well. And I'm not going to do the hands and the fingers right now, even though I could, but just for times, I'm going to skip through that. And first, I actually want to do an FK transfer. So we could do a full body, but we also have this other mode, which is you're just transferring the kind of local rotations across. And this works really well for some cases. So in some cases, the full body IK works better. In some cases, the FK transfer works better. It really depends on the animation and the use case. So both are available. At any point, you can modify that pose a little bit. So here, I'm going to have to enable the target so I can actually change it. And I can kind of just fiddle with that a little bit. You can see maybe the arms are going a little bit too much through the body, so I want to fix that. Then we can kind of, as the animation is being retargeted, we can actually move the arm out a little bit just because we weren't too happy with the solve. Sometimes the clavicle or the hands give us trouble, so we can fix that. We can also drop a full body IK, then use that instead of the FK transfer and see the result that gives us. And this is, again, the faults. And you can see full body IK just solves things a little bit better. And that's usually the preferred way that I choose to retarget. You can see here that at this point, you have a retargeting system set up for you that works pretty well. At any point, you can just delete that old part of it, just clean up the network a little bit. And then here, I'm going to add some offset. So here, it's not the best to add an offset before you do the rig match pose because that is going to calculate some offsets based on it. But if you do, down here, it will do what you expect. So you can basically change the incoming animation before it goes into the full body IK, or you can change the result after it runs through the full body IK. So at any point, if the arms are going through places or you need to kind of move the feet a little bit or adjust anything, you have full agency of where everything is going. And once you set this setup once, which again, 3 nodes, you can basically swap out this animation import with different files on disk and retarget a whole lot of them. And luckily for us, we have just the thing in PDG. So PDG, again, 2 nodes. We can use the file pattern node or file pattern top to find all of the different FBX on a disk or on a directory. And here you can see that by clicking on the work item, that actually enables that work item and sets up the scene to be able to visualize. So we can quickly just spot check all of our animations and see if they're being retargeted properly. We can visualize the original one and the retarget. And when we're happy, we can just say, all right, let's do this. And it will process, in my case, 16 in the same at the same time, parallel. And if you have a farm, you can actually throw this on a farm and do 1,000. So I think we did the whole Carnegie Mellon data set, which is around over 1,000 in about an hour on a local machine. So if you do have a large data set that you're kind of scared of retargeting because it's going to take time, this should help you a lot. And this should help make your life a little bit easier so you're not scared of retargeting at all at the animation set. You can do it, see what it results, and then do it again. And not be super scared of doing that operation. This would be a little bit of a dance break. So this is some awesome retargets that our developer Mihnea did. And it's just showing a bunch of different Mixamo and Paragon characters being retargeted to motion. And just to show again how varied the characters can be. And I'm going to get into this guy a little bit more next. But you can see how it's a really robust system, and really this is the kind of the key offering that we have. It is our retargeting system. We're really proud. We worked a lot on it, and it works really, really well. So I'll keep things moving along. You get the idea. So let's talk about this Iggy character a little bit more. So again, this is one of Paragon's characters that Epic has put up, and I'm just the cool thing here is that it is 2 separate characters that are just one large skeleton. So when I saw it and we were looking at the characters to retarget, I was like, this looks kind of like a Halloween costume. So it looks like those riders where the lower body is the creature and then the upper body is the rider. So I wanted to retarget human emotion to him, ideally mocap. So that was the kind of crazy thought of kind of live mocapping onto this character. So we tried it and it works pretty well. So here we have the original source data being retargeted to a minimized skeleton. It is still the same bones from the full skeleton, but just so we can visualize it and we can solve the full body IK a little bit easier, we kind of isolated the kind of hierarchy that would make a human hierarchy or close to a human hierarchy from it. And then we just apply those motions back onto the full skeleton. So you see a few things fall apart. The head kind of wobbles a lot. And then the feet are just kind of going through the character. He's just kind of dangling there, his little legs. And ideally, we do some stuff with like an IK chain to kind of pin the feet sideways and do some stabilization on both the tail and the head. So it looks a little bit more lively. So that's what I have to show you here. And this is actually a lot of information at the same time, but we have some integrations with Unreal and some mocap suits. So I'm going to be talking more in depth on those here coming up, but I just want to show this. We have, I'm wearing a mocap suit that is going into the Axis Neuron, which is Perception Neuron's software for capturing or for translating the mocap data. That goes into Houdini, which does the translation between the human to the character. And then that is using the Unreal Live link to actually stream straight into it. And if you notice the legs of the rider, they are being constrained to the deformed version of the creature. And we're also kind of offsetting the rider a little bit up and stabilizing the head and the tail. So you can see here, we're seeing a little bit of the head stabilization. And I can just act out, and you can see my upper body is being transferred to the rider. His legs are just pinned to the creature. And my legs are being passed over as well. So let's talk a little bit about these integrations, because this is a really cool feature. This is actually part of Labs, so we're going to be releasing those nodes through Labs. And the Unreal Live Link is going to be its own plugin. So it's going to be its own project, much like the Niagara plugin. And it has its own repository. So the two suits that we've partnered up with is the Perception Neuron. Perception Neuron Studio suit in particular is the one that I was using there. And then we also partner with Rococo, and of course with Epic and the Unreal Live Link. So I'm going to show a little bit about those integrations here, starting with the Unreal Live Link and how it is to set it up. So this Hive talk also doubles as documentation because I'm leaving and there's only so much time on a day. So here we're going to go straight into the Live Link and how it is to set it up. So here on the Houdini side, it's basically a node, and you funnel that into whatever you want to send to Unreal, and you hit Start Server. This actually starts a web server that then the Houdini Live Link will connect to. At that time, you will have a Houdini subject available to you. So if you change in your skeletal mesh, so it's the link preview and it's using the right character, now data should be being sent back and forth. So now we can either have mocaps running through it, but in this case, I just wanted to show it the most basic, which is I'm just going to throw again my rig pose, and I'm going to move the arm around, and then you can see just how fast it is. So basically, Unreal is currently pinging that web server for information, and as you're updating your pose, that streams across and it works. So even if you want to see full materials, you can set that all up in Houdini, or you can just use it, the Live Link, and kind of see the full character in all its glory. So now let's take a look at this retargeting for this character. So this character is a little more complicated. So it's Crunch, and you can see here it actually does some really nice stuff. I'm going to break it down here in a second. And again, the Live Link is still working back there. So as I'm visualizing a full animation, I can still have that kind of feedback happening on a separate screen or on a separate monitor. And the cool thing here is that I'm actually doing both tricks. So the upper body is using an FK transfer, and the lower body is using a full body IK. And then we have some other of those rig attribute FOPs for all the little pistons on this character. So all of those you can see are being resolved properly. I'm going to show what happens when that's off. And you can see this is pretty interactive frame rates for both sides. So if we go here and we disable the pistons, you should see that those don't update anymore and they're kind of sticking out from the side. If we turn them on, it will fix themselves. So even this network is live and things are updating as we move across it. So here again, rig match pose, map points, configure full body IK, which is one node that I didn't touch, but basically does the same weighting that you could do on the full body IK node itself. We have an FK transfer and a full body transfer. And then this rig pose is actually, its job is to kill the hand. So you can see my fingers are actually not working here. And that is because I actually need to kill the motion of my wrist on this particular character. And here we can see if we disable the blend, it kind of works. So this is just what the full body IK is doing. So you can see the hand is pretty bad. Again, we need that rig pose. And just the upper body doesn't solve as well. It's kind of a complicated character with a lot of joints. So the full body IK struggles a little bit. So in this case, the FK transfer is actually the best way of doing the upper body just because of the way the character is set up. And the lower body is using the regular full body solve. So here again, we can see the pistons. Those are just being updated right after. So again, if you used a state machine before, this is your bread and butter, right? So you have two animations coming in. We used to call this sausaging back when we were working on production, to where basically lower body is doing one thing, upper body is doing another thing. And then you're playing some actual procedural setup. In this case, it's baked, but theoretically you could be doing this at runtime. And then I'm just adding a rig pose and just hand animating so we can visualize what those beautiful pistons are doing. So if we turn that off, you can see that the bases don't update. And if we update those, they all work. And these are just basic game constraints. You basically just say one joint, look at another joint, and that's all it takes to set these up. But again, pretty fast, pretty reactive. And next we're going to look at how to set up the Axis Neuron setup. So here I have a similar animation. The thing that we have to go into the Axis Neuron is to actually go to our settings. So here, if we go to settings, there's actually, you can broadcast the capturing or you can broadcast the editing. So in this case, I'm broadcasting the editing. Make a note of which port you're broadcasting out of. And you're just going to drop a neuron node. And then you set the IP to the one you want. You say connected. And then you just funnel that in as you would. So now the animation is kind of streaming in live. So if I scrub on my neuron or if I'm having live capture, you can see that's coming through, passing through Houdini, and you can see Unreal in the background, still hooked up, still doing stuff. So even if I change my network, you can see that everything still continues to flow through. And now instead of a range of motion, I'm doing this awesome kicking sequence. And again, you can see what's happening on the actual character. And you can do this live, which is what I'll show you here in a second. But I just wanted to show you what the setup looked like. So again, very, very simple. You just have to, and you can change an animation on the neuron side as well. And you can see it changes it on the Unreal. So theoretically, you can even have Houdini running in the background and not open at all. And just everything is running. And you're only dealing with the neuron and the Unreal, or you can have Houdini open and playing with that as well. And again, this is just showing, this was actually when I captured the motion that I just demoed, but instead of broadcasting the edit, I'm broadcasting the live. So here you can see the perception neuron has great fingers that mapped properly and kind of come across. And as you're doing these motions, you can notice that I can be a little more careful with my emotions, and I can take a look at see when things are going to be crashing into each other or where I need to add a little bit of an offset to my motion to make sure that things are going to look right on the character. And it feels cool. It feels like you're actually the character, and you feel like you're strong, and actually you can bring more into your performance by actually seeing what the final character is going to look like. You can see here everything is still working. We still have the pistons all firing, everything streaming. Pretty great frame rates, no struggle on any side, and kind of running across multiple software. And then here's the Rococo setup. So for this one, we go into the Studio Live. In this case, we're going through custom and just making sure we're on JSON version 3 and UDP. By the time this is released, hopefully we'll have a Houdini icon in there, and you'll just be able to set that up. And then again, very similarly, you just hit connect and everything will kind of come through. So in this case, we have this stake with 3 different characters. And again, very similar setup to what we had with the other setup. And in this case, we actually do support props and multiple characters. So here it just comes through, and you have an actor name point attribute that you can do to set things up. And this is just getting the data, but you can kind of go a little bit more crazier and actually set up full characters with deformation and actually have the 3 characters coming through and playing the setup at the same time. You can see here we start to take a little bit of a hit, but it's up to you to kind of determine what quality you want and what kind of data you might want to see. Here's another setup where we have a camera also being tracked and kind of coming across. I just copied 2 points, a pig head to it. So we can see we just got a big blob of characters and the cameras, and then you can basically do whatever you want. So in our case, we're just doing some blasts to isolate it, which is actually the reason why the other scene is a little slow. Blasts are slow. So now that I think about it, you probably just want to do a group or on the full body. And yeah, so that's the Rococo integration. coming through with props. So there's actually one prop that's just placed on the bottom, and then the other one that's coming through, and we're retargeting that for all intents and purposes onto the same similar skeleton. So a couple of more things. So at the ground level, we talked about how bones are points. And if you extract that up a level in time, you have animations or geometry caches. And then the next concept that I'm going to introduce here is motion clips. And it's essentially a motion cache, geometry cache, it's basically a motion cache all at once. So you're seeing the whole geometry cache, all of the frames at once, similar to the trail SOP, if you're familiar with that. So in this motion, we're gonna have an animation that I wanna cycle. So basically we have this clip. First thing I wanna do is use the extract locomotion to actually kill the locomotion from the hip. So here I can just say my root motion is coming from the hip, so I wanna neutralize that. And then the motion clip is what actually unfolds it out into 4D time and basically makes it so it's not time dependent. So if you notice, there's a little green badge next to the extract motion that is not on the motion clip. That means it's time dependent. And we can kind of change it as well. By making it non-time dependent, it just means it's going to cook faster. And it allows you to operate on the neighboring frames, which is something that we can't do if we only have one frame available to you. Again, they're just regular points that you can do whatever you want for it. But in this case, we're actually running it through the motion clip cycle, and then motion clip evaluate will kind of bring us back into the single frame. So I just played that one more time. So we have the animations coming in. We use extract locomotion to kill the root motion, so we're cycling in place. And you can say which axis you want to kill. In this case, we're going to give us back the y-axis. We're converting it to a motion clip. At this point, we can do all sorts of crazy stuff and lopping off the feed and smoothing just the feed, feeding that into a full body IK, you name it. I'm just going to feed it through a cycle so it kind of blends. And then the evaluate will kind of get us back into a single frame at a time. And I actually didn't like the motion on the hips because it kind of floated up. So I'm going to do that. I could fix it with the rig pose and just manually kind of fudge it. But in this case, I'd just rather kill it. So now that we have this little setup, we're going to do something the next level up, which is I'm going to duplicate that. I'm going to paste a different animation, and I want to do my sausaging of upper body and lower body. So I want to take this motion and I want to do that skeleton blend that I did with the crunch character. I'm going to set up a group mask so you can see how easy it is. So I can just basically say upper body joints are going to come from the different animation, and you can see here I can just feed it to my existing chain and it will do the looping and the cycling. But in this case, it's actually looping the beginning of the animation, which is not what I want. So I'm going to use a time shift node to shift my animation forward in time by around 50 or 60 frames. So because I don't really care about that beginning where the arms goes up, I just want where it's actually up already. So you can see here I shifted that time. And now if I look at my looping animation, it has the updated arms. So again, if you're familiar with state machines, this should be very, very familiar to you. And you can see this is the beginning of a clip editor or like a nonlinear editor. So again, we need some more UI to get to that, but rest assured, we're looking into that. So the final thing I want to talk about is custom rigs. So whenever I demo this, everybody's like, oh, these are cool lines and dots. Can I actually do my NURBS art that I like to do so much? So here we have again our Eric model from Christoph Desi, and I made a custom rig just to demonstrate a very simple one, but I'll show you how it is. So here I have a name constraint looking at the pig head, and I have my IK controllers to kind of do my hand. I have FK on the arms. I can go in and pose my arms. I can go into my fingers. There are different colors. I can select multiples of them and do my finger curls. So this should start feeling more like what you'd expect out of a rigging system. But the trick here is that it is still very much procedural. So I can the rig is actually attaching to an animated setup. So in this case, I moved my arm and then the rig kind of builds itself there and then detaches it. So that's what we have. It's similar to the concept of ephemeral rigging. Not all the way there because the ephemeral is going to be purely on the viewport. But this is more of the kind of just-in-time rig where you can say it's a micro rig. Maybe I lopped off the peg head for just as a name constraint, or maybe they're different rigs. So in this case, they're just the same one that I can chain them together, and you can see I can override them. But the thought would be that an animator could select and be like, I want a different hand rig, I want a different upper body rig, I want to set up things a little bit differently. So here we can actually start looking at, it feels like it's an animation layer where every layer has its own rig. And then we can kind of start coming in here and seeing what's happening. So you can see we have a visibility stop, which I actually have to go up one level and operate on, bypass another one because that's the one that's hiding it. So we can see what's happening. So here I'm setting the hands to be yellow, creating some extra bones for my controllers. Again, very similar concepts that you should be familiar with right now. And then we have this actual attached control geometry. The compute rig pose is where we're going to inject our setup, and then we can basically do an attribute copy and then finally feed it into a rig attribute to do the actual calculations. But if at any point I want to change my rig, it's very easy. So here I didn't like the pig head. I wanted a different controller, and just to show that controllers are just pieces of geometry that are essentially copy to points onto the actual controls. That's what we have. So here you can see I changed it, but I was missing controls on the spine. So that's something that my animators complained to me, and they say, hey, we need that. We need a new HDA that has that setup. So I can come here to my control geometry. I can just say, okay, add another entry, and the controllers already exist, right? Because they're already just the bones. You can duplicate more and make separate ones, but in this case, I just want to kind of parent them directly. And I want to make them my large circle, and I want to make that circle a little bit larger. And there you have it. Now I have skeleton controls or spine controls that I can go in, I can animate, and my animators are free. I can make a version 2.0 of the rig. It's just an HDA. And the next time they open their scene, it can be updated. Or they can manually bump the versions. So it's up to them. So again, this is the very beginning of a full rigging system. This is admittedly the part that still has a little bit more to come, but it's possible now. And for people that are probably looking at this, they're already fearless and going into something new. If you want to go a little bit deeper into the rabbit hole, rest assured we got your back, and it does support all of the things you want it to support. So I know it was a long presentation, big overview. Main takeaway, rigging now is in SOPs. So that is a fundamental change to rigging and animation that I'm super thrilled to be able to say that we got through. We're focusing mainly on dense data processing, even though you just saw that we can do regular hand key animation, very much driven, much like a state machine. So if you're familiar with the state machine, you'll feel right at home, and is the very first of many updates. So this is the foundational level. There's lots of things that we know need to come, and we're working hard to give it to you. So finally, I want to say again, thank you. You've been amazing. This was my last presentation. I'm sure I'll see everybody online. If I see you at a conference, feel free to ask for a drink. I have nothing but gratitude for everything this community has done to me. And I'm going to miss everybody. I'll still be online. But yeah, I'm going to miss traveling the world and seeing everybody in their native environment. So thank you once again, and hopefully this was illuminating. I know Henry Dean, who really did the majority of the work here that I presented, is going to be doing a masterclass or a presentation, so keep an eye out for that. And again, once again, thank you very much for this opportunity, and I'll see you guys on the flip side.